Let's start. I would like to invite our Dean, Professor Rolin Davchev, to say again a few words before continuing with the next.
Thank you, Sveti. Hello, everyone. I'm extremely excited that this important moment is a real fact today about the first graduating class of the Master of Science program, Computational and Advanced Design. This event is happening in parallel with a very special period for UACEG, when in this year we celebrate the 80th anniversary of the university. The initiative to create a new master's degree program started only 3 years ago, when together with Pavlina and Sveti we initiated the organization, and together we went through the difficult challenges such as administration and organization of the whole process. The small and ambitious team behind the program really demonstrated great enthusiasm and potential. Thanks to their incredible efforts, they did everything possible to make this idea come true today. I would like to warmly congratulate all the tutors and students who have made unbelievable efforts and show remarkable results at very high level. I'm not hiding that in the beginning there was certain skepticism among my colleagues at the university about the significance and feasibility of the program as a trendy and short-lived impulse, as an overly ambitious and adventurous initiative. I'm extremely happy that all these fears have been dismissed, and you have all proved the opposite. Everyone at the university and our guests were very impressed by the exhibition with your projects at the foyer. I was also very happy to hear that
I think we lost him for a second.
Yes, again, we have
a little bit towards the end, but I think at least we heard the first part this time, but it's great. Thank you so much,
I think the internet is okay. The final presentations from yesterday were very impressive and show a really high level today, and can't wait to see even better results. I wish you everyone a successful graduation, and I'm really so proud of all of you. Thank you.
Thank you, Professor.
Thank you so much, Professor Davchev. Thank you.
Thank you. Thank you for sharing all this with everyone. It's important to, like talk about these things, because we often see, endeavors taking up, and like the master's degree, like being so successful, like so many students, like learning so much and really like are ready to navigate their next challenges in their design journey. And it's great to, like be open and talk about exactly like the challenges, like everything that, how change is made, right? Like it's not always everyone that is going to embrace it or understand it or have faith in it. But at the end of the day, like it's about like staying true to your ideas and to, like what drives you and what you love. So I really wish that everyone from, like our students and, like they also like have the same drive and, like not take no for an answer, and keep moving forward with something that is very meaningful and that it's not going away. Computational and advanced design is the future of design. It is going to bring more and more opportunities for our community, and we're very proud and very thankful to the university that embraced this. A university, again, like deeply rooted in tradition, but they took the leap with us. So thank you so much, Professor Davchev, and the university. Thank you. Before we start, today, we are going to have a little announcement. We have Michael Pell with us, the director of Microsoft Garage. Hi, Mike.
Hey, hi. Hey, everyone.
We have a small announcement to make, basically a surprise for the students. We are going to have our first year where we're going to collaborate with Microsoft Garage, and Mike has been so kind and has invited us all to New York to join him for a couple of days of a workshop in November. So thank you so much, Mike. That means so much to us.
It means a lot to me too. The Microsoft Garage program, excuse me, is an innovation program worldwide. And the things that we do are help people take their passion and their ideas and move them forward. I can't think of a better thing to do with all of you than have you come to New York, get together in person, take some of those ideas and some of that passion and turn it into learning for all of us. So I'm incredibly excited to host everyone. Can't wait to see what we do together.
Thank you so much. That's going to be actually our first opportunity to get to meet each other in person for the first time. So that's why this is very special for this group. Thank you for the opportunity. We're humbled. We're very excited for it. And I think it's a great day to start, a great way to start the day today.
Yeah, I just put in the chat window something you should look at, not now, but later. It's just a backgrounder on the Microsoft Garage program around the world, what we do with Microsoft employees and our partners and you know, even our customers. It's really about taking your ideas and making them real. So hope to see all of you in New York, and I can't wait to see what you're going to present this morning.
Thank you.
Thank you. Amazing news. Sorry.
Yes, super exciting.
It will be amazing beginning of November in New York. We are also inviting the students from the next year who will start their studies in September. So it will be very interesting.
Yes. Okay, thank you. So hello, my name is Doukhi, and I am the core lead of the second group. Okay, let's hope that we can match yesterday's presentations, or even better, I don't know. Okay, so we start with B2, Alice and Sam.
Hello, everyone.
Hello, hello.
Hello.
We're excited to share our project with you and everyone. Okay. So hi, I'm Alice.
Hi, I'm Sam.
And over the last 9 months, we learned and, so over the last 9 months, we learned and utilized various programs to develop our storyline and build the world of EndoSim. As you can see through the progression of prosthesis, corpuscle, amalgamation, kinesis, and a cosmogony level. Our thesis mainly explores the idea of growth. Therefore, we explored specific tools to convey and build our method from Bifrost and particle simulations to various algorithms in Houdini. It was important to find balance in designing our idea as well as allowing it to carry its own life as a testament to our vision of establishing symbiosis with nature. We look forward to bringing you along this journey and entering the world of EndoSim. Currently, drastic events such as the pandemic are creating a world without touch. As a solution, we've built barriers between us and everything we interact with, objects, our environment, and even amongst each other. Sterilizing bacteria and isolation have been our proposed solution. However, these answers bring about new problems. How does one form community during times of isolation? Can the sense of touch truly be recreated? In other words, how does one experience touch without touching? We propose EndoSim, a solution to regain connectivity as a species and transform humanity's parasitic relationship with the world to a symbiotic one. EndoSim is derived from the word endosymbiosis, which describes a symbiotic relationship between two coexisting organisms. We based our research from sea animals that utilize symbiotic relationship with electromagnetic bacteria on their body to increase connectivity as a species. We believe that by finding balance between this organic matter and the man-made parts of our society, we will be able to find connection between our species while allowing us to live sustainably with our ecosystem. We will symbiotically rebuild each connection from a microscale. Like a domino effect, this bacteria will be the interface organism between all connections. The building block in the glue that provides connectivity.
Sorry, the images are not loaded.
I think everything was loaded when I first shared, and then I think it's.
Yeah, just reload mirror maybe.
Yeah, yeah, I had everything loaded. Sorry, when I first shared this. It might need to take
I think you should keep going. The slides are showing fine. So I would, for that person that's having trouble, maybe rejoin, but I would keep going.
Oh, you're able to see the images? Okay, thank you. Yeah,
I'm not. That's interesting. I don't see. No,
yeah.
Here.
Me neither.
Yeah. Okay. I can't see them either now.
Oh,
just reload Miro. It's fine.
Yeah. Reload. Okay. Sorry about that, everyone.
It's going to in the next second. Don't worry about it.
Okay. Yeah, sometimes when it goes to the presentation mode, it kind of resets everything, and I think maybe it has to do that. Okay, hopefully. I can just start from the beginning, from this page as well, just to kind of give some context.
Yep, it's fine.
Okay, perfect. Okay, so we'll start from the beginning. Thank you. So we will symbiotically rebuild each connection from a microscale like a domino effect. This bacteria will be the interface organism between all connections, the building block and the glue that provides connectivity and clean oxygen, transforming humans into vital nutrition for our ecosystem from one level at a time.
Our first stage of implementation is our prosthesis. We selected various bacteria that will be hosted on the body, similar to the sea animals that utilizes this relationship. Here are the essential bacteria for the endosym. The magnetotactic bacteria being the most crucial one, creating an increased connectivity and additional electromagnetic sense of touch. The cyanobacteria, which synthesizes clean oxygen. E. coli, which is naturally found in the human gut. And finally, a biofilm created by the conglomeration of these various bacteria. This recipe of bacteria will be implemented on a spine structure that is placed on a host at adolescence. This new structure is 3D printed with a bio-based material containing the bacteria, which allows it to grow and act similar to an additional sensory organ on the body. The bacteria starts to grow within the structure. As you can see, the organism thrives off the printed material, eventually expanding beyond the spine. At the stage 3, the bacteria exceeds the structure and begins to grow compatibility with the body. The biofilm begins encapsulating the body like a second skin, and at adolescence, all bacteria types are now finally visible. Each variation interacts with another, as they play key roles in enhancing communication while simultaneously filtering the air. Over time, the biofilm, cyanobacteria, E. coli, and most importantly, the electromagnetic bacteria will reach the pinnacle growth and effectiveness. Finally, the host will be entirely encapsulated with bacteria as they fuse into one form and one collective identity. At this stage, the host is as at its peak ability to connect with other humans and their surroundings. As the host ages and reaches the end of life, the bacteria will eventually consume the host, becoming the crucial interface organism between life and death, propagating new life and nutrition for the environment.
As we continue to the corpuscle level, the architecture will similarly host this bacteria like a trellis in order to transform our currently isolated and polluted human environments into seeds of life and hubs of connectivity. The unit is able to connect in a variety of ways in order to introduce new architectural landscapes and communal opportunities. Bacteria will be the connection point or glue that connects each unit to one another. Here are some external images of the units in the site. They utilize the existing structure to redefine new spaces and utilize the remnants of the cityscape. Each unit is designed to promote interactivity and connectivity as seen in the diagram. The layout features co-working spaces, communal dining, and various other social landscapes is seen by human interaction. Here are close-ups of these interior spaces. The bacteria upholsters the walls and floors as they interact with the humans who cohabit them. The more the communal spaces are utilized, the more bacteria will grow and propagate and uphold the purpose of EndoSim.
We analyzed the city of New York and how this system of growth and rejuvenation could be implemented into each neighborhood, similar to existing Highline, by connecting isolating environments with more communal areas. We created various connection types between the units, such as the shuriken that acts as a connector or bridges in between existing buildings. Here is how our system will grow and interact with the existing cityscape. We started in Manhattan, a highly dense and polluted city. We analyzed the Meatpacking District, Upper East Side, and Midtown in order to showcase the vast and dynamic options of connectivity. We customized the amalgamation of each borough to address specific qualities dependent on foot traffic, tourism, or residential areas. In the Upper East Side, there is a net output of commuters leaving the zone each day. Therefore, we enhance connection points to key commercial districts. The amount of connections is less dense because it is primarily residential, and we utilize connections to the rooftops to create more open space. In the Meatpacking District, which is a mix of small shopping complexes and museums, we enhance bridge connections within the area to promote small businesses and prevent congregation in only certain zones. The amalgamation is moderately dense due to tourism and commuters. And finally, we arrive to Midtown, or family known as Times Square. This zone has one of the highest influxes of tourists and commuters each day in the entire world. The connection points are increased within the area to allow tourists to mobilize within the area, as well as long connections for commuters coming from surrounding areas and needing quick and effective transit. The public zones are formed with the amalgamation of shuriken structures that serve as park of lush, bacteria, and life in order to break up the dense city zones. These large areas are essential in transforming these concrete jungles to life again. Here is the final image showing the integration of this system implemented into Manhattan.
On the kinesis level, implementing public and private transportation accessible to the whole population. They follow winding networks that allow bacteria to be distributed throughout the city and increase connection between neighborhoods. We use growth as a basis to enhance connections between the city. The winding paths are created in order to make as many connections as possible in order to promote socialization. The more foot traffic that is intertwined, the greater sense of community is established. Here's a map of growth and implementation of this logic. The vehicles are all meant to be public use. Here we have the individual unit used as a rideshare. The bacteria is stored underneath the vehicle. The rideshare stations are located inside the shuriken. The tracks are based off of electromagnetic propulsion propulsion for movement, and utilize magnetic attraction to secure the parking on the walls. The tree of life structure congregates the bacteria in the center as a powerhouse. The public transit is implemented throughout the city and accumulates bacteria from the commuters, preserving the bacteria underneath for movement. The public stations are shared with the private stations and are located underneath in order to create swift transfers between and accessibility between all transit units. Here's a final realization of this Kinesis implementation. 1 second.
As we move to our final stage of cosmogony, we utilize the logic of this dense congregated city zones as a powerhouse to distribute and channel these bacteria to outer rural areas, revitalizing and rejuvenating environments that are on the verge of being unlivable. I will walk through the logic of our cosmogony phase from a micro to a macro scale. The bacteria serves as the interface organism for all connections. The denser the growth, the more connectivity and cleaner air is produced in the zone. Ferrofluids is an electromagnetic polarized liquid, which we utilize as a channel to attract the growth of bacteria. Additionally, we integrated subwave maps to understand how these zones could be connected with existing channels beneath the surface. This network of ferrofluids will act similarly to an irrigation system, bringing nutrients to surrounding rural areas and unlivable zones. Visually comparable to a rich life that surrounds the Nile River in the Eastern Desert, these channels will attract new growth of bacteria and start the building blocks of life again. These channels will attract new growth of bacteria and the things. We also translated the slime mold logic using nuclide plugin on Grasshopper to create underground networks where the ferrofluids will be redirected from the city. These are our trials in combining these two separate logics into one harmonious and symbiotic system, balancing man-made structure and organic ferrofluid networks. Here is a breakdown of each component in the network. We begin with the contours defining New York City, surrounded by the Hudson River. The organic ferrofluid network are specifically constructed beneath the Hudson River as a means of bringing the electromagnetic charge from Manhattan to the surrounding areas. The subway connections utilize existing underground networks to distribute the congregating zones of bacteria. The amalgamation sprout with life in areas of rich bacteria. The public zones are encircled by these dense areas as powerhouses and sources of energy that eventually funnel into a river networks. Here is a growth analysis of the ferrofluid distributing through the network. The network of endosym transforms polluted environments and elements of humanity into sources of rich nutrition and life. Each relationship codependent and symbiotic with each other. As nature is in a constant desire to self-balance, the cosmogony network acts similarly in distributing a balancing as a way to propagate a new life, a new future for our species and for our planet. And now we will show you a glimpse into a world of endosym. Thank you.
Can you share music? Sam, can you share the music?
Oh, you can't hear the music too?
No.
Maybe the YouTube version? Can you hear now?
Yes.
Okay.
No, again, like we can't hear it.
Yeah, you need to share with music video on. Yeah, we still cannot hear it.
Oh, I'm sorry, there's no music.
No, yeah, can you share with?
Yeah, of course.
Yeah.
Maybe it's.
Now we can hear it.
Oh, now you can hear it?
Yeah, maybe if you make it louder.
Okay.
Might help a little bit, because like in the beginning we can hear it, but then like it's like disappearing as it goes. So let's just make it a little bit louder, and if it doesn't work, it's okay. Like we'll watch it on YouTube on our own.
Sorry about that. Thank you.
That's okay. Don't worry about it.
Thank you so much.
Thank you. Just a note, if you can watch the video on YouTube, because sometimes Zoom just make the video super laggy. So that's for the audience.
Homeowner 2020. Sorry. Okay, got it. Thank you.
That's a good point. Thank you so much, Sam and Ali's beautiful work. A very exciting project. It has been from the beginning. I'm excited to see like everything coming together. Definitely such high quality work from the first chapter to the end, and now like we see even in the video like how amazing this new space that you're creating, new city, new life is. So thank you so much for this amazing project and for being with us like throughout this year. It's been an amazing journey. I wanted to ask you actually even starting with this bacteria, what was your first source of inspiration? Because as we know, with all these projects, the students are coming up with their own ideas of what matters to them and how they see the future being, how the future is going to happen. And that's Sam and Alice's idea of their view of the future. So I was wondering, like, what was the initial instinct, like, to go towards that direction? Was it because, like, we were still like in this pandemic, and like, was that like some of the inspiration that you were gathering from?
Yeah, I definitely think a huge part of it is the fact that this program is so international. Everyone is coming from all different parts of the world, but we're still coming together and communicating and sort of interacting with each other. And I think that part of the interaction and how Sam and I actually have never met in person is pretty amazing, that we were able to kind of build and create this project together. So I think that was really like kind of the root of like, how do humans communicate and interact during these times, and what are ways that we could further push that without being so removed in many ways. And also for me, my background is in material design, so much of it has to do with connection and physical touch, and it was a big transition to move to doing computational design. So that was kind of from my perspective.
Oh, Sam, you're muted.
Oh, Sam, you're muted.
Sorry. And I will add that it's also kind of like an analysis of our actual state right now, in which even though we have all these technologies that are supposed to bring us closer together, like you also see an increase of like people being aloof and built into their own spaces, that was also enhanced by all this COVID situation. And what we wanted was kind of to create a provocation towards this like hypo-isolation that we have created, as well as these like hypoallergenic spaces that we have created through all this pandemic, in which we are like cleaning our hands 2, 3, 4, 5, 6 times per second almost. And in reality, we live and interact constantly with bacteria. And these bacteria, like not all bacteria are bad for us. Like the majority of them, we created a symbiotic relationship with them that allows us to survive, like the coli that grows inside of your human gut, and it like helps your system. And it's kind of like take a look at that and a view at like at that, and reconsider what is the relationship that we are thinking about, that we are creating with our surroundings, and everyone from like other people to ourselves to like the bacteria that surround us and nature in itself.
Thank you, guys.
Yeah, very well done, guys. Really, you guys have stunning visuals, and right from the start till the end, it's quite coherent, and you have a wonderful concept. I think overall you've done really brilliant work. Just fascinated to see how all the chapters they've evolved, and they look really great. Congratulations.
Thank you so much.
Congratulations also from me. It's an amazing project. And I really love your design language from the beginning until the end. It's all coherent, and it's really nice. Thank you so much.
Thank you, Elena.
Thank you.
Very pink too.
One comment from my side. I'm Giovanni from Pininfarina. Good afternoon or good morning, everyone. So I remember this project from the interim meeting, and I see that it evolved in a very coherent way. I mean, as like everyone said, it took to my mind one sentence that says that, architecture is our third skin. Our dress, because our dress is our second skin, and we have our own skin. And what I like of this project is that in a way, you are bringing all three together, no? And your aesthetic is very much coherent across, all these different scales, including also mobility. One question that I have, I'm not sure whether I have asked this during the interim meeting, but have you thought about, using the bacteria as not just as a interaction or connection tissue, but also as a way to self-construct the infrastructure themselves? Because I understand that your idea now is to build like large pieces of infrastructure with like traditional technologies such as concrete or steel or other things. And and then to allow the bacteria to grow in or around it. Why not, you know, the bacteria, they build themselves the infrastructure. I mean, this could be a vision. But anyway, overall, congratulations.
Thank you very much. Yeah, I mean, certainly we, the way we thought about it was more like as the bacteria being intertwined with the structures, which open like the opportunity for the bacteria to overgrow that and create its own spaces, but at the same time it serves as the seeds and like kind of like the skeletal for like this bacteria to like produce, because humanity moves in a really like has fast pace, while the bacteria like growth takes a little bit more time. So it was kind of like a mixture of allowing the bacteria to have like the freedom of growth, but at the same time having a starting point from which it doesn't stop like the movement of society at the same time, and to be also be able to put society in itself into the equation of the bacteria growth, because like the conglomeration of people in the different places, it is what enhances the growth of this bacteria.
Yeah, and I think we kind of wanted to imagine that transformation of where we live right now into that world. So kind of like the growth itself, so that it doesn't feel too much like we're jumping into an entirely new place and it's too unfamiliar. So we wanted the progression to be that way, and maybe we imagine that eventually that would be, you know, the next part of it would be kind of growing these newer worlds and developments after a cosmogony phase.
I was just wondering if you guys had a chance to experiment with the real bacteria. Did you guys do some studies with it?
With the real bacteria?
Yeah.
Yeah, that was something we initially really we really were hoping to do. I think there were some bio like hazard concerns of growing it in just our houses, but I think eventually it would be a very exciting part to imagine, like 3D printing it and seeing how.
Yeah.
Any other comments?
Yes,
Yeah.
congratulations. Sorry, congratulations from my side. Really amazing project. I've already said that several times, but again, and also very interesting video. So indeed, a really good job in everything.
Thank you so much.
Yeah, congratulations. I had to watch this on mobile phone because I was running around. But even on that small scale, it's amazing how consistent it was across all the scales and how richly developed your project really is. And looking forward to watching a playback on YouTube where I can see the images a little bigger.
Thank you. Thank you for watching.
Thank you.
Okay.
Yeah, it's a little bit loud here. I'm in the middle of a city, but I watched your presentation as well, and I just love to see your process, how that literally grew, sort of, you know, and it's just really beautiful to see. So congratulations.
Thank you very much.
Thank you.
Thank you, Sam and Alice. It was a pleasure working together. It was super fun, I guess. So thank you for the experience. And looking forward to the next.
Before we move on, I just want to add something. I think that what we've heard actually from Manoj, it's a valid point, right? Like it's there are two kinds of like presentations like within the masters right now. One is like more focused on the experiential part of like the storytelling, like, and they're not going so much like into the details of like how actually things were made. And I understand that that's something that's quite interesting too, right? Because there are a lot of aspects on the technical side that in order to create this cohesive story, you've actually rediscovered your system in many ways in order to make these transitions. And I actually, before we move forward, I wanted to ask you about like this you know, like transitions that you had, like the softwares that you were using, like your, you know, like experience with it, and also like it was an interesting like team between you, because again, Sam, like you had already experience in computational design. Alice, like you're hands-on like materials designer, and you know, like it's a very interesting team, again, like coming from this interdisciplinary background. And I want just to hear like about a little bit more about like the ways that you approach the project, and also you know, like how this teamwork worked for you.
Sam, do you want to go, or?
You can go first.
Okay. No, you can go. Sorry, I have a train. I have some.
Okay, we already see how it works. It's like, oh, you go, no, you go.
No, I think, well, I mean, I think one of the best parts of this, you know, one of the most exciting parts was, you know, working with Sam. I'm really gonna miss our regular phone calls and interaction. Like, it was almost, I feel like we were roommates, you know, because we were always there in each other's presence. And I think it was a very interesting collaboration. Like, there's definitely different lenses in terms of how we focus on, you know, achieving things. And Sam having this parametric background, I think we're able to really like evolve and focus a lot on this growth aspect. You know, which was definitely a challenge, because I think it utilized very much parts of the program that weren't as straightforward to me, and I was still trying to, you know, learn some of the basics of like 3D modeling and things like that. But I think, you know, for me, I focus a lot on like the texture and materiality of things and the finishing, and so it was really fun to kind of find the intersection of that point. And you know, I think that the materiality and sort of like the ends visualization of everything, I think was you know, some of the things that really came to life the most. But yeah.
Yeah, no, I mean, I will definitely agree with that. I mean, it was certainly super interesting because, as Ali say, like, she's a material designer. She's focusing that super like kind of like micro scale and the detail of like the materials and etc. While I have an education or a background in like architecture, and even though in architecture you're supposed to go to the details and etc., you're more used to like the big scale and the out of it. So it was kind of interesting to have that collision and like be able to constantly jump between micro to macro, and to put like more thought in like the materiality and all of that. I guess the only big thing that I just pushed for was to include pink into our project.
Yeah, that was the thing.
That was our only fight, I guess. It was like at the start, it was like, oh, but I want pink, and she's like, I don't know about that. No. It's gonna look cool.
Drawn on me. I like pink now.
That's interesting to hear. What about the technical aspect, guys? Like on the softwares, like how did you evolve the project? Because like in the beginning, we started with the Maya polygonal modeling, and then like you transitioned into more advanced techniques, computational design techniques with Grasshopper, Houdini. So you know, I think it's interesting also like to hear from that side, like, you know, like some of the workflows that you used in order to utilize and to have this cohesive story from chapter 1 to the last one, right? Because you are building your skills as you're making the project, but then like we see this project like being, you know, like super cohesive like throughout all of them. So what's your secret there?
Well, that was actually super challenging because, as you say, we started with poly modeling, and then we were introduced by particle, like the standard particle simulation in Maya. And I guess from the start, we were looking for a way that we can like create a simulation of something that is growing. We didn't want to like model all the details ourselves, but we wanted to kind of like create like the sense or like give some space for the model to like grow itself. And once we found like the particle system in Maya, we started exploring that and trying to go more deep into it. That at that point we end up at Bifrost, which is basically Grasshopper for Grasshopper, but for Maya. which was kind of interesting to explore, kind of complicated. It has, the interface is super different and it's not like as easy to go through. And from that, we just started basically every chapter to kind of like rediscover how to translate that into the different scales, especially because the definition there, it's like becomes really heavy at the time of the simulation. So we, like for the kinesis level, for example, we explore how to translate that simulation of particles moving around into like Houdini to optimize that different growth. We also try it in Grasshopper in different ways, but it wasn't kind of like the best approach. So we had to like jump from all the programs and trying to like understand and find a way on creating these simulations of bacteria growing from different perspectives, I guess. So I guess that was the most challenging part, but that also is like the part that was, or that creates the cohesiveness through the program, right?
Yeah, we were definitely dependent on using kind of all the programs, as Sam said, you know, and I think that that's what, you know, this was about, was all the connections between all the different types of growth. So it's cool to be able to see those come to life all in one place.
Thank you, guys. Thank you so much.
I have is it okay if I ask a quick question just before we move on?
Of
So
course.
I love the vision. I was saying in the chat, as somebody who lives in New York City, it was super interesting. So you can do all this design work. Did you have conversations about the ethics of going to a more organic world, to augmenting, you know, the human body with these things? Was that part of your design process to delve into the morality and ethics of it?
I think it definitely like came about. That's really interesting to like kind of propose that question, because I think it definitely, regardless, comes up when you're designing, of like how intrusive that would be for the body, and especially I think during this time when we are so hyper aware of, you know, like hygiene and like interacting with our environments and bacteria. So we didn't dive too far into that space, but I mean, definitely when we were just like designing you know, the spaces that people are interacting, we were thinking like, what is too much growth and what is too much for the human body, and when does it no longer almost become a human body? Like, when does it kind of lose the human qualities of it when you're so covered in bacteria? And we were trying to really find what's the balance of, you know, taking it too far in that space. I think for like some of us, like, I mean, I think when we were talking about it, we were kind of like, let's push it as much as possible. Like, let's see what that sort of border is, and you know, where we wanted to kind of hit, I think, that zone and that space. But in the beginning, we were wondering, you know, like how much to push it, which I think the concept of growth was really important to it, so that you could see that development and it didn't feel like too much of a jump.
Well, I mean, some of the scariest visions are the most profound, right? Because they pose questions that are deep and difficult to answer. It doesn't mean that you shouldn't keep exploring and push it as far as you like. I was a little shocked when you said that we turn into mush at the end. I wasn't expecting that, but okay. But it's great. It's a beautiful vision. It's very insightful and very, I would say, stimulating to think about, could that actually be a direction? So thank you for the work. It's fantastic.
Thank you. I think when you're thinking about like life and growth, you really have to think about the full cycle of it. So that was definitely like a very, you know, that I think definitely when we're talking about the prosthesis level too, that was really like a conversation we had to think about, was the holistic part of it.
Mm-hmm. Yeah, we try to like go like through all the like process as itself and to really think, because like we started actually all of this from understanding the fact that in reality you never touch anything, right? And we even like went down the rabbit hole and like kind of like investigate a lot of like quantum physics to understand the fact that like actually like molecules in itself doesn't like touch each other because they repel because the electromagnetic fields. And then from there is what it started like as the proposing question of like, how do you touch without touching, and how do you can recreate that sense of touching in itself? But also like one thing that I will say based on like what you said earlier, is that, I mean, in terms of ethics, like technology or like advancement is very ambiguous, right? Because like the same technology that allow us to connect right now and share all together through computers is the same technology that allow us to kind of like destroy the world with missiles, right? So it just depends on how you use the tools that we created.
Can I say something?
Hello.
So I was thinking what Mike is telling and what Samuel is talking about, like, you know, since COVID has like the past couple of years, and you see so many mutations there. Do you agree with that? And say you're like merging human life with, you know, a lot of bacteria, and don't you see, you know, new mutations coming in? And like Samuel, you're talking about like, you know, computers and you know, bio stuff. That's not comparable. I'll tell you why. I mean, see, you can have a lot of mutations going on. I mean, in the past 2 years, you've seen a lot of COVID variations, Delta, Omicron, etc., etc. Don't you think we'll have more mutations, more problems coming together? And this cannot be compared to a computer, actually. I mean, computer is a digital device. It just stays like that. I mean, you just keep on evolving, but it's still in control. I mean, this is the reason why we have moved from horses to cars. Horses' performance might not be consistent. Car is consistent, more or less it's consistent. You just have to fuel it, you can just ride it again. That's not the case with horse. I mean, they need to rest, etc. So that's not comparable. It's not an ideal comparison. And like Mike is telling, yeah, I mean, it's definitely a concern. I understand this is all hypothetical, and since you have told that you have thought of all these things, I think you should think of these things as well. Biology doesn't stay the same. It keeps on evolving. That's the nature of life.
Maybe that's a very literal approach to look at it. And in the micro world, things are different.
Very different.
Yes.
Yeah, but
and biology is very unpredictable. The reason,
I mean,
you know.
Yes, yeah, totally true what you're saying. Like it continues growing and it's something that is like more in a constant change. But like, why is it that a bad thing, right? Like that's just because we have the perception of like this reality that we have created based on things that are more static, and we have created that way because we feel more comfortable having the illusion that we have control over things. But in reality, we don't truly have control over any of those things. And even like if you create like these static things, what is the lifespan of these static things, right? We have like a car that only lasts like up to like a certain time, or even like a building will destroy itself with time. So they are also in a constant change. We just try to like make it as slow as possible. But what if instead of like running of this fact that is like the constant change of everything, Pantarei in itself, we just embrace it because it's just part of our nature. Humans as itself are constantly changing, growing and dying.
I think
the rate of evolution is very different.
I think one thing that we're thinking about is oftentimes we design for our generation now. Things are very much designed to like, we are kind of defying a lot of like our evolutionary development because we're designing so much for the moment that it actually makes our adjustment and to the larger world, like past our lives, almost harder because we get a little bit more and more removed from our environment and from our world. So we were trying to think of something that kind of outlasts like our lifetime, you know, thinking of how it'll affect like a larger and longer term of growth.
Okay, like coming back to Samuel, I think the comparison is still not right again. The wear and tear of car is very different. The evolution rate of human is very different. The rate of, you know, something like a virus, like a living being is very different. I mean, how many evolutions have you seen in the past 2 years of humans?
Sorry,
like from some Homo sapien to, did you see something else in humans?
Yeah, here we're looking.
But yeah, when you look at COVID like virus, it's a living being, right? You see a lot of variations in a very short span in a couple of years. So I think the comparison is not right again.
If I can jump in, I would like to congratulate the team. I think one thing that maybe we're not thinking about is that we are actually, you know, as humans are reliant on bacteria a lot today because our bodies cannot function on Earth or on another planet without those bacteria. So I think that's, if you think of it that way, that's a way of thinking that we need to think about more and more, and it's more important to think about our relationship with the world at many different scales. And one scale is the bacterial scale, another scale is the plant scale, then all like a geological scale, and all of these scales. And I think it's very relevant to think also right now of the bacteria, especially after COVID and all that stuff.
Thank you, Dimitri.
Yeah, I agree as well, and I agree with Alice as well. That when she was talking about designing not just for our generation but also for future generations, because I guess I think the path that we are on currently, and when we think about 100 years, 200 years down the line, and the aspirations of our current generations in terms of moving into different planets. And so I guess these kind of studies and these kind of visions are very much necessary to think about, because they would be there might be a point when these things do become real things. So yep.
Thank you, Kiyor. Ali, I see like you've raised your hand.
Yeah, well, I think firstly, congratulations. I think it was just a fantastic visual and experience just to see all the vibrant colors. And with the conversation, I would like to add that, of course, there's these realistic factors that exist within the world, but we need to explore, we need to push boundaries, we need to explore these ideas about what if this happens. So I think looking from that perspective, it's provided so much insight. So amazing, really. So thank you.
Thank you everyone for your comments. Let's move forward to the next team, so we have time to have more discussions and more comments. It's going to be a lot of provocative projects. So
yes, so let's move on to B3, Pedro and Nadia. Just a note, just so we are in the time frame, we have 15 minutes for comments and discussion. Thank you.
Yes. Okay. Welcome. Pedro, ready?
Yeah, sorry. Please go on.
Okay. Welcome to ALMA. We are Nadia Kutyreva and Pedro Venegas. Before we dive into World of ALMA, we would like to share our design journey with you. Every chapter we discuss what we are interested in learning personally and try to solve our creative tasks with instruments of our interest. With every chapter, the workflow was changing and evolving. We grew our tool set. We learned how not to be afraid of ZBrush and Houdini. We discovered our love for Arnold renderer and procedural materials in our first chapter, and we met for it. We are very grateful for Design Masters' way of guiding us on this journey. Before the program, both of us had skills in some software, but it was grains of sand compared to waterfall of instruments that we tried during creation of the ALMA. But following our own professional interest and focusing on the strong story, we were able to apply all new knowledge and create a unique, a beautiful world that we are ready to present for you.
Welcome to the world of ALMA. Since the dawn of humanity, we have always tried to control and understand the world around us. Ideas of great complexity, such as time and the scale of the universe, are beyond human perception. The idea behind this project is mankind to confronting the unknown, to find a way to understand hyper-complex processes like global climate crisis and mass extinction we experience now, and shift civilization to prosperity and balance. We propose a radical solution: enhancement of human brain by creative artificial intelligence. Complementary properties of organic and artificial brains make collaboration and innovation across time and space possible. The society that is based on such augmentation will develop core attributes: communication, data exchangeability, and autonomy. This sketch was our aha moment and triggered the vision for the project. We call it ALMA, Autonomous Living Machine Algorithm. We wanted ALMA to be welcoming and alive. How will this augmentation change humans, and how will humans change the world? Let's find out.
To make the blended biosynthetic mind, we propose the collection of augmentation tool. Despite the very same principle at the core, the ALMA will look different for every person. It depends on the personality and professional interest of the host. We use the collection of implant and non-wearables that gives ALMA people the ability to collect and analyze the data of the world, enhancing not only physical limitation, but cognitive abilities. The most important part are invasive implants that integrate into the central nervous system directly in the zones where main nerves exchange data. Data from organic and digital senses merged in one biosynthetic mind. The next level is customized non-invasive collection of wearables that have double function, augmented physical abilities, and exchange data with ALMA through physical visualization with bioluminescent data streams inside the wearables. The third level is sensors. They enhance the natural senses and extend them to the full electromagnetic spectrum. And the final level is digital aura, the virtual level that expresses the psychological and empathetic state of the host. ALMA adapts, grows, and learns with its host. The diversity of our ALMA experiences bring people the ability to express personality and being true to yourself that leads to the unique data that can be shared with the collective.
ALMA human evolved brain is always in the hunt for data that can be harvested and understood. In their search, ALMA people left the Earth and became space sailors. Their settlements are located around planetary orbits, and they are part of a complex network we call the data river, the streams of people, cargo, and data inside society. One of these orbits is the low satellite orbit, where resources from the Earth are delivered to space. On the other hand, the geostationary is the farthest orbit, where gigafactories forge products from the resources coming from deep space. And the most populated is habitable orbit, where most of the settlements are. It's a dense and vibrant area. To distribute resources inside the network, ALMA people travel through two special transport networks. One is ALMA-I, the intermodal logistic network located between geostationary and habitable orbits. The most vital is the transit orbit, which peers all other ones, transporting physical and digital goods through the global network. When vehicles of transit orbit intersects the network of settlement and habitable orbit, a transition event happens. During this event, two orbital networks collide, intersecting and entwining. The streams of both orbits have different properties like density, direction, data type, etc. All of these influence each other's behavior, creating a unique micronetwork. The spatial collective infrastructure, as recycling centers, data storages, and research facilities are located between settlements. Here, the ALMA society stores, analyzes, and researches the data on the collective level. On the top of the network, there are starters that are the core of any settlement, and the deployment of the neighborhood is happening around the starters and along with the network. So now it's time to go even closer.
ALMA settlements are a vibrant community of space travelers. Regular size is up to 5,000 ships aggregated together. As we mentioned, the centerpiece of any settlements are starters, oasis-like structure, which are placed in the strategic trade of travel routes near the planet. Each of the starter works as a beacon and has a dedicated function of life support, water and food, artificial nature, or gigafactory to build new ships. The next step is the growth of connectivity tissue that grows outward and connects starters into one system. Here you see how a different number of starters and privacy trust communication settings develop a pattern of the connectivity tissue. Secondary local public spaces are smaller than starters, but they're important as they create the community and empower neighborhoods. After the initial kickoff, the tissue solidifies. It creates the main structure, bones, that gives tunnel for transportation system, protection, and a base for aggregation of living units. Next step is arrival of settlers. From the beginning, potential residents have a lot of options of where and how to join the community. Bonds provide the space for any type of neighborhood, from permanent to temporary. Closer to starters, permanent residents who choose to drop out engine systems. This type of neighborhood is the most trustworthy and the most knowledgeable of the society. They analyze the data the nomads bring to them and put it into the collective knowledge of library. Nomads, at the other end, prefer to settle in clusters at the periphery of bonds. It gives them ability to arrive and leave the settlements at any time. They are constantly on a mission for hunting data. The life in the settlements never sleeps. Variety of special cupolas allow Alma people to contemplate and appreciate the beauty of the earth and deep space. When the future settlers arrive, they fly through data gates, the collective digital aura rings, and the newcomers synchronize their data and the experience with the community. Data gates are trust filter and a data protection for the knowledge of the settlement.
Constant movement is in the core of the settlement. So Alma people develop various vehicles for short and long distance trips. The main corpuscle, the private space hopper, and a public vehicle, the space worm. The smallest in the family is the space hopper, fast and agile. It jumps around the clusters, personified data of the owner that express itself as a skeleton pattern. 360-degree rotational wings, stabilization technology, and 12 thrusters allow this vehicle to be precise in the movement. 10 strong but accurate manipulators will take care of the mothership and repair damage that ships gain in space missions. AI augmented. The hopper is fully autonomous. It looks for the shortest path to destination and avoids the others in the system. Their service area is short trips inside cluster only. So now let's go further. Let's switch the vehicle. Here is a mighty space worm travel unit. Each one can carry up 10 people, and assembled units can carry up 200 people. Each unit consists of passenger capsules and cargo unit. Every space worm can be assembled with different arrangement. The pattern and light system works as physical data visualization and express the collective data of the community it belongs to. A unique ability of the worms is that they are versatile and can travel safely inside the tunnels of the bones, as well as in the open deep space. To travel through Alma settlement, the passengers took hopper that park at the main airlock of the corpuscle. They travel through the cluster from settlement to the hubs, where transit stations are located. On the station, passengers switch from the space worm using dedicated platform simultaneously. Cargo units are installed and filled with goods and data. Fully assembled, space worms go through tunnels to the main station that's located in the starter. And from there, it travels to a destination through the Alma I intermodal.
The apex of the Alma technology is the corpuscle, the mobile living unit, a spaceship, a home, a friend in long deep space missions. It consists of two main parts, the womb, which sustain and protect life inside, and a chrysalis, the engines, as well additional protection, energy, and a product storage. As any other part of Alma tech, corpuscles links to their host with a special device called Spot, the essential unit for the management of data, knowledge, and experiences. In addition, the Spot takes care of pilot wellness through forced synesthesia experiences. The Spot is connected to the heart of every ship, a core, the AI of the corpuscle, which stores and protects the data and takes care of ship and inhabitants. The link between Alma host and the core grows through time, so the core AI learns and evolves with their pilot. Architecture of the corpuscle is multi-layered. First, the exoskeleton, which pattern represents the personified data of the host similar to other vehicles. Second, transparent protective shell. And final, the life support system that provide necessary environmental comfort, and the light coding system works similar to prosthesis veins, carrying visible data for exchange with other corpuscles. There are multiple levitating platforms inside, each with a special functionality. Food and variables production system, private quarters, control deck, and others. The main one is recreation platform, where inhabitants can receive the sensorial experiences for their well-being. The core is a part of this area. It provides data exchange and access to the data library of the ALMA collective. But the crowning jewel of the ship is contemplation area. The overview effect helps ALMA people strengthen their bond with the earth, their communities, and appreciate the beauty of the vast deep space. The ALMA people are very sensitive to the fragile beauty of nature. Their society keeps the balance between technology and nature for other generations to come.
This is how the world of people with AI-augmented minds might look like. From the individual to the collective, from the inanimate to the living, from the settlement to the planet. ALMA will give the ability to share experiences, emotions, knowledge, and information through collective networks of biosynthetic minds. This will transcend humanity to the next level of technological progress and cultural evolution alike. So now, let's go to experience the ALMA world as close as we can be. Thank you so much.
Thank you.
Thank you.
Wow, you guys really left me speechless. I think that in the chat
we all are speechless. Wow.
In the chat, they were saying how epic that was.
That's good.
We are waiting for the whole movie.
We too.
Yeah, that would be nice. So exciting, guys, so exciting. Such an amazing project, like such a journey. just, you know, like such beautiful visuals, also like the whole story, the way that you're conveying it, you know, like I know like how many times like you've rehearsed also like throughout the chapters, like presenting this, like always in this like very unique way, like of representation. So you've definitely like mastered it. It's beautiful. It's beautiful work. So really congratulations from me.
Thank you so much.
Thank you.
Yeah, it's really awe-inspiring. And also we got a sneak preview of this project last year in October at the Chicago Architecture Biennial when you were just in stage 2, I think. And just the amazing development that you've done since then is just staggering. It's so beautiful. And I guess a question that I would have to you, because it's really something that I'm thinking about a lot regarding how the metaverse is really going to transform what we build and how we build things in real life. And I mean, as an architect, of course, I'm always interested in the built environment, but also in the interlacing of the metaverse with the real environment. So I'm looking at some of these spatial configurations, and of course, this is the dream that everyone has, like, let's build these kinds of things in reality. But I'm wondering how you envision real built structures interacting with these kinds of environments so that we can have windows into opportunities that we really can't create in real life very easily. I mean, have you guys thought about that as designers, or do you care about that? Do you see these purely as kind of fictitious scenarios that are like futuristic, or how do you regard what you're doing in relationship?
It's actually interesting question, because our vision that we stay in physical world, but we enhance our physical world with all these digital sensorial experiences. That this is why we have implants in brain. We don't need VR sets to have virtual reality around us. We just directly show pictures inside the brain. So yeah, and to build this world, this was our goal. We're in the space and we did our material research. Our project looks extremely fragile, transparent on purpose. We wanted to show this fragility of the world, but at the same time, material-wise, we research what is the latest and greatest in the space industry, and they have transparent materials that can protect us in the space. So nothing, of course, it's a very huge stretch to the future, but all materials that you can see on our devices, they are pretty much existing now. Some of them ancient ones like metals, but they just need a little bit push for the future to become a real material, like transparent, radiative, protective polymers.
Yeah,
So,
sure. In addition, we discussed a lot about materials. Even though we did our own research about it, we found that even NASA has a very special program for material studies in low orbit, and basically they are polymers. I mean, in this kind of we didn't decide to go that technical just due to the time, but probably if we give more time studying materials, we can even tell the exact material we are planning to use right now, because the information is there. NASA has a lot of technical information about it, about transparent materials, polymers, metals, and materials that are generally they are testing right now in outer space.
Yeah, but I guess my real question goes beyond sort of materializing these physically as material exercises, because I think it's quite credible most of what you've shown can be manufactured possibly with high performance materials. My question has to do with like user experience and performance, spatial performance, and how some of these, like a lot of these experiences, as you've shown them, are relatively solitary experiences where you have a very low density population and many kind of nooks and crannies into which you can kind of crawl and be by yourself. And so, I mean, long before we go to Mars with this design, I think it would be really great to produce some of these kinds of designs on Earth. And so I guess the idea of social functionality of spatial configurations that are complex and legible all those things really enter into the conversation. And I mean, as spaces are very beautiful, and there's a lot of imagination that's going on here. But as kind of built environments, or even environments that are extensions into the metaverse from real spaces, I really kind of question what happens when you get a higher density population interacting.
Yeah, we
Like
built our world for introverts. Yeah, but joking aside, we out of scope of our project, but in our minds, we have public areas inside the starters and in local spaces where they have these community spaces and giant plazas to hang out and to communicate with each other. And also because they have Alma AI, Alma augmented brain, they don't need other people to be physically with them. So they can be connected to anyone, anywhere in the universe right away. So this is what we can explore, like blend of physical and digital world, that there's no difference between them. So we don't, in our project, we don't split for physical world and metaverse, we just merge it together.
I guess the other
the question.
sort of, I mean, the other question, I mean, I'm one of these people that also believes like sitting in your room with a headset and interacting completely in imaginative space is not really something that, not the way I would want to live my life, at least. So, I mean, I would argue that indeed, like just having purely virtual or AI driven connectivity is still going to be a far cry from what people really desire to have. And so I guess I would love for you guys to push this forward just one step and show one of these interactive spaces where perhaps you can have physical co-presencing in addition to this AI or kind of metaverse kind of extension.
Yeah,
that would be
we have glimpse to that. Like this, our main platform is a dancing party scene there, so they have a party there.
Yeah, the idea behind the main capsule is that it's more or less we more or less took the idea of the embryological house, in where every host has the ability to create its own house depending on what they want, if they want to live alone or not. If they want to live with 10 people, it's possible. It should be possible. So the idea is that every vehicle is completely different depending on the host needs.
Yeah, quick comment from my side. Well, first of all, congratulations for the way you structured the narrative. I think this was very effective, and this is very important because, you know, like some of us, like myself, for example, are looking at the project for the first time. So having a nice narrative allows us, you know, to understand completely, you know, the idea, and this is very important. Just a small critique. Sometimes you see very nice shapes, but you don't have a reference of the size. Also because you moved into space, you know, so sometimes I think it's necessary to give to the people, to the user, a clear understanding of how big the objects are. Overall, the aesthetic is amazing, and I think you know, you decided to confront with space that from one side leaves you a lot of freedom, and from the other side, you know, like when we think about space, there is a very I would say unique vision of space, of design of objects in space, and it's very difficult to move far from that. I think you were able to do it, you know, to create your own categories and paradigms of design, because this is something that is completely detached from everything we know. Just a quick question, what was your inspiration? You know, because in the group before, it was pretty clear that they started with the bacteria and then they moved on. But in your case, you know, where did you start from to create such a unique environment?
Pedro, do you want to ask that?
That's a pretty good question. I mean, even though I personally have a very strong inspiration in the Art Nouveau style, probably, personally speaking, probably that's why I try to push that idea computationally speaking. But regarding the image, we actually didn't have too much references. But we were aware that we want to work more like a liquid. You know, we try to explore that kind of detail modeling. I mean, we try to be more liquid, if I may say. So I don't know, Nadia, if you want to add something.
Yeah, and also we don't believe in sci-fi future sciencey look, like futuristic, when everything is white and steel and everyone is a scientist, you know. Not, we believe in vibrant, colorful worlds that people will be unique and do stupid things and do good things and bad things. Like people will always people. So we want to have this living, vibrant world that's very connected to nature. As Pedro said, that we have artificial nature because we try to save our planet in our project. And also two initial points at the very first beginning, at the very first meeting with me and Pedro was, he said, let's do creative AI. And I said, let's do colors. Like, that's it. That was the first input, and everything we just, okay, how we'll do it. And this is how and Pedro, if you put the top there, our aha moment, and we experiment and messing around with shapes, and we design this, what we call turtle. So when we literally inspired ourselves, so when we are not joking, when we see this organic matter covered with a plastic semi-translucent shell, we thought, okay, this is our vision. This is literally look like we want to go there and see more of this, how it will grow into aesthetic. So you saw how to grow, how it was grown.
Thank you. Maybe one last comment before we move on.
If I can interject.
Yes,
I love
sure.
the project, guys. I mean, the progress was just amazing. Seeing it all come together in the end is like a fantastic experience. So a big congratulations to the both of you. Suppose if I had a question, I really liked the sort of distinction that you made in the prosthesis chapter in particular, and you're kind of creating these ideas of how the prosthesis would be administered, like the distinction between something that might be invasive or non-invasive. I was also thinking, like, I'm really interested in whether you were thinking about the life cycle of these prosthetics, or whether they're permanently, let's say, personalized to one individual, or whether there's some kind of interaction between them, or can they be exchanged? Can they have some kind of life cycle that does not depend on one user? And whether that was something that you would find interesting to explore.
Yeah, the main idea was that spinal cord implants, they're permanent because they physically inside the human body. But as for non-invasive wearables, they can mix and match. They can use, maybe they can use others, but because they're highly personalized and shaped to the body, probably you cannot swap with your friends. But the idea is that they're made out of biodegradable material and use biotech to the core. So we can recycle them and print new one and on demand. So for example, in our story, Zoe, the girl, she's a choreographer, and Cusco, he is an astronaut. But let's assume that Zoe decided to go to the space mission. So she's now an astronaut. So she can build and printed her new prosthetics the same that Cusco has, but it will look different. Even in that case, it will look different for her because she has different data to start with. She has different personality, and also she has different shapes. So even that same number of prosthesis parts will be on her, they will definitely look different. And if Cusco decided to dance, so his costume probably will be without leotards, or maybe with, I don't know.
We also discussed the lifetime of the digital data. I mean, the data, the non-physical data. At the beginning, we discussed this idea of use the concept of blockchain to share the common knowledge once a physical body died. But from every chapter, we decided not to talk about it too much because it's a really deep concept to try to discover in a very short master plan. But the idea was to, once a human died, all the knowledge that was gathered through our implant can be shared to the common knowledge. So the idea is that the knowledge never dies, you know.
Yeah, we can explore that in the next team.
Or the next master.
No.
In two teams.
In two teams, yes, in two teams. Sorry.
Yeah, this is my people for you. Thank you, guys.
Thank you guys. It was an amazing experience working with you. You were so consistent. Like 9 months, just 9 months hardcore, going to like 6th gear. Just straight up every time. So many things to discuss.
Thank you.
Thank you. Thank you so
Thanks
much.
for your patience too.
Yes.
Okay, so move on to next team. We have Pradeep and Manoj.
Yeah, hello.
Hello.
Yes. Hello everyone. This is Pradeep and Manoj. We are group morphogenic neutrons. Our curiosity began with analysis of human
Deep, I'm
brains.
sorry, I will have to stop you, but like you have the same challenges. One of the groups yesterday where on the top you have a line. Yes, this is like grayed out and it might cut off some of your images.
Yeah.
Okay, perfect. Thank you.
No, I think now it's in the middle of the screen. Yeah.
Yes, now it's not. Yeah.
So yeah, we start again. So hello everyone. This is Pradeep and Manoj. We are group morphogenic neutrons. Our curiosity began with analysis of human brain. Human brain is largest in proportion to its body weight, yet it is underdeveloped in spatial understanding. We dissect spaces into 2D planes, while birds and many other organisms are able to understand spaces better in 3D. Our project focuses on enhancing the spatial awareness and cognitive ability by developing modular units, inspired from games like Lego and building blocks. We explore a modular system in replacing many of the existing technologies and all scales of usability, from human extension to building a city and integration of this technology into human culture.
We envision a transformative living through a modular system that can be self-assembled and are adapted to the human needs. One of our inspirations is from the movie Big Hero 6, where the protagonist controls the microbots to create structures. A similar phenomenon is also observed in bird flocks, swarming of fire ants, where complex stars are overcoming individual limitations are achieved through modular aggregation. We take influence from 2 research projects on modular self-assembly system, the hypercell and the envelope, which we influence for the technical working of our modular unit.
We name our modular unit microbot as AFA, Artificial Fire Ants. The movement of our AFA units are by principles of electromagnetism and torque movement. To ensure optimal usage, topological optimization and shortest path algorithms are used in each aggregation.
Prosthetics being used over 80 million people to restore their lost body functions. Our exploration started with AFA replacing a regular prosthetic that can be aggregated to both walking and running limbs prosthetics, overcoming the limitation of the conventional single function modes. In our progression, we identified the requirement for faster movement of the AFAs around the body, anchor points for support structures in aggregation, and neurotransmitter to communicate with the AFA units. This led us to the development of Rail Suit, and we call the humans using this technology as nootropic humans. The suit consists of 3 components and a brain implant, a bodysuit, and a rail component. The AI-powered brain transmitter facilitates communication and optimization of the aggregation. The bodysuit acts as a vital catalyst in providing a solution for a safe and faster movement of the AFA. The rail component in an assembly of the modular, upgradable units embedded with circuits to facilitate faster AFA movements. The rail suit addresses 2 other key challenges by providing anchor points for the aggregation and an integrated container that can be attached to the suit for the storage of AFAs.
Our exploration continued in a scalar progression with consequent increase in the number of AFA units. The dragon-like extension with 5 million AFA shows the aggregation, processing, and providing body anchors and necessary load transfer to ground, while with 50 million AFA, human exoskeleton is formed. To fulfill the AFAs required for such large aggregation, dynamic storages like an AFA pit can be one solution, which can disintegrate and facilitate larger aggregation. View of our nootropic humans planning for the next big aggregation.
Advancing our exploration and development of a nootropic home with modular AFA system was first explored in Libya. Considering its quick need and revamp and infrastructure and abundance of resources to produce AFA units, and to substitute materials with varying properties used in conventional constructions, additional three topologies of AFS were developed. The development of nootropic homes starts with prefabricated floor plates being deployed at the site. Subsequent AFAs start aggregating on the floor plates, which by topological optimization form the exoskeleton. Further, the AFAs are deployed, which anchor to the exoskeleton and wrap around the structure for later use. The wrapped AFAs aggregate to adaptive enclosures on the exterior.
The four typologies of AFAs used in the order of their deployment with properties best suiting its functions. A nootropic home is designed for co-living spaces consisting of living, sleeping, utility, and experimental lab area. The primary movement inside our corpuscle is through the vertical transportation tunnel powered by AFA platforms. The AFAs wrapped in the interiors, when put to use, forms the formwork for the furniture, on top of which the soft cushioned furniture AFAs are aggregated. Are young humans envisioning the feasibility of a nootropic neighborhood?
In exploring the potential of neighborhoods formed by the nootropic humans, our corpuscle units are required to be supplemented with starter units, VPG units, vending and power generation units, recreational lab units, sleeping pods, and AFA storage units to facilitate for a nootropic living. The connection catalog can be understood as three major rule sets as follows. The starter units connect each other on either axis to form the amalgamation. Starter units connection between the corpuscle to other units such as bedding and lab and VPG units, and followed by the public to the AFS storage connection.
The deployment starts with VPG units being strategically placed at site, which vents the AFA spreading along the ground, creating a platform. To facilitate the aggregation of starter units, the position and orientation of which governs the shape and height of the tower, the circular courtyards are created by sideways connection of starter units, which becomes the formwork and acts as a structural base for further aggregation of the tower. The aggregation of the starter unit further continues in height and stops as its formwork threshold is reached to open up for corpuscles to join for further formation of towers. Then the additional VPG units are aggregated onto the exterior to satisfy the energy requirement. As the towers are now habitable, the nootropic humans start aggregating supplementary units, such as per the needs of the users. The initial units that were spread on the ground as platform now becomes landscape areas and part of urban furniture, thus creating the public spaces at ground level. This deployment logic helped us evolve our nootropic living with towering clusters with central open and recreational space, thus always ensuring a better quality of living. Our amalgamation showing the quality of life with ample landscape and open areas for dynamic development in future.
And humans enjoying the tower clusters and looking for exploring ways to connecting to each other's clusters. As we step on to move around our nootropic living, our amalgamation proves to the network system, whereas to establish typologies of AFAs act as a distinct part that are required for the vehicles. Semi-public networks are in the central courtyard of each cluster travels across the height, primarily connecting to the recreational lab unit of each cluster. Whereas the public unit travels along the exterior of the tower, interconnecting the VPG units of the cluster, forming neighborhood networks. The VPG units being strategically placed one for every 145 units ensures the uniform distribution and access to the public network system within accessible distance. A private vehicle is a system of three distinctive layers of AFS mounted on top of two spherical wheels. Inferencing from the research Orbitron, spherical wheels were adopted to facilitate sudden angular movements, turns, and rotations. For the private vehicle, SFVs create the structural framework over the wheels and through optimization strategies. Subsequently, AFAs form a layer of soft cushion to accommodate the needs of the rider. Protective gear enclosing the AFAs are aggregated with increasing speed for the safety of the rider.
The public vehicle is powered by private vehicles in a modular manner at two levels, solving the conventional problem of public transportation not being used entirely during certain hours of the day. At the first level, the private vehicles establish a connection between each other to create a framework for the public vehicle. At the second level, the chassis is formed on the framework through topological optimization. This interrelation and modularity of public units with private units ensure optimal usage of energy and available resources. View of the parking with spherical wheels that are used by hand humans prototyping a vehicle. The built vehicle is tested for quality and its readiness to depart is through the illuminated portal.
As nootropic humans emerge and have their pilot development successfully established and need for establishing a cityscape to understand the truest potential of AFS and transformative logic becomes inevitable. There begins the story of NCPs. The deployment of the starter units happened along the water bodies. These clusters produce AFAs and expand to form subsequent clusters around them. The AFA movement from the starter to the new clusters become a primary connection between one to another, which keeps mutating to form the cities and districts. The animation represents the growth of our entities that are transformative and adaptive to the change over time and the needs of the inhabitants, thus making it a city of change, solving the constraints adaptive to witness in the nominative plan. Then our master plan is a system of multiple cities with minimum association and association-free networks between the clusters. The network of their interrelationship can be identified from yellow to violet gradation in the network system. The places with high topological difference are reserved for the development of public spaces with minimum intervention to the topology.
The regional network is through well-established connection between various cities to organize social, economic, environmental, and spatial distribution of resources. Areas of close connection form the centers. The city network with thicker connection represents area of key movement and secondary connection and fainter connections. Our map constantly evolves and establishes networks that are sustainable, adaptive, and transformative, similar to the behavior observed in slime mold, which exhibits a collective intelligence to create optimized networks, thus staying true to our transformative logic and self-assembly system of our project. Thank you.
So here is a glimpse of the entities.
The audio is not playing.
Yeah, there is no audio.
Oh, sorry.
You can share with audio, yes.
I'm just starting over. Can you hear it now?
Yes, all good.
Thank you.
Thank you.
Beautiful work, beautiful project. I have a soft spot for it because you used the hypercell as one of your starting points. So, you know, I can't help it as a co-creator of the system. So I'm super excited to see this system come to life actually in our master's degree. It's very exciting to see exactly the logic that you're, building up with, and all the different computational design strategies also that you, followed in order to create your world. So congratulations for me, really amazing work. And I'm super, super proud of you guys, for putting all this together, because working throughout these challenges of project that was again based on self-assembly. I know that it's difficult to push the boundaries, and I'm happy to see that you use the technologies that already have been, have been looked into and developed, and this actually makes your storytelling much stronger, right? So congrats for me.
Thank you.
Thank you.
Yeah, congratulations. It's a nice project. Actually, I do have a question about that, like the genesis of the Hypercell project out of the Spiropolis studio and AADRL and all those experiments in robotic self-assembly really were not at all about cyberspace or like a cinematic, fantastical, or kind of metaverse experience. So I'm kind of questioning why you wanted to have this kind of hyper voxelized aesthetic and utility in cyberspace, and whether that was intended in order to be able to actualize these projects as self-assembling systems.
It's a very good question. So our initial thought was, so I was particularly more fascinated with human brains and how it works. And although I'm not too, I've not dug too technical on it, but I've read many papers which support the development of us to this stage of evolution, just with some interventions in our lifestyle. For example, cooking being a huge part in evolution of human brain. So I was thinking, if there is a huge difference between human brain, how they think, and how animals think with a less primitive brain, what can be the intervention into our human life that can change this way that we think, not dissecting everything into details. And that with an additional question that it should be easy to understand. I mean, it should be easy for every human to understand. And a game that reminds me is the blocks that we used to play as kids to understand understand how the shapes work with each other, interact with each other, was one supporting thing for me. And we decided to make the geometry as simple as possible, helping humans to create their own 3D spaces. And the best thing was that helped us was Minecraft. Like when we were seeing the game Minecraft, it has this complex world built in it, but everything is so simple and comes down to a simple box. How do you place boxes together, and how do you see those spaces? I hope that answered your question, and that's where we...
Yeah, I mean, I really appreciate that idea, because when you have users that are kind of building out their own spaces, kind of explaining that logic visually to them. But I think like building hypervoxelized spaces, specifically in cyberspace or in the metaverse, I mean, I'm foreseeing a time very soon when we're going to create parametric tools that are going to be used by end users in Unreal Engine 5. And of course, the aesthetic in Unreal Engine 5 is very far away from like CryptoVoxels or Sandbox, where you necessarily have to create using voxels. What is really interesting about this voxelized kind of trajectory of Hypercell and other projects that came out of that studio is the potential for robotic self-assembly. And I guess in order to strengthen your project, maybe you want to add like a layer that kind of addresses that, because that would really be the real world application of what you're doing. Not so much, you know, building in the metaverse, because very soon we're going to have tools that far exceed what we've had so far. And also obviously capacity with Unreal Engine 5 to create things that move far beyond hypervoxelization.
There was an initial thought to add robotics or use the help of robots to create these volumes, but then how do I say this? The realness of this being an end result of human imagination was limited, and it again constructs with using robotics in the middle, like how the robots actually make this volume a reality. So what we decided was to make the units autonomous itself, so that the AI transmitter that we're talking about can convert these shapes into voxels and may suggest the voxels to go to that location. And then we see the movement in such ways. That's the idea. Why we chose to make it more autonomous than use robots to build the units.
Hi, just a question kind of connected to this. I was lucky as well to be in DRL when Pavlina was working with the hypercell. So I had a fair dose of hypercell when I was there. So yeah, like something that, I mean, maybe I didn't capture it when I was watching the presentation, are like when you're using your units, like let's say when you are developing the living space, are those living spaces transforming over time? Or because like what I see is like they're kind of more like fixed forms, which I think like, you know, like if I were to compare with a Theo Studio, I think it's like the idea of reconfigurability and the potential of, you know, evolutionary architecture is where the real strength of these kind of self-assembly, like, you know, like ecosystems, let's call them, is. Are you like kind of considering that, like, is this space is transforming, or is kind of a fixed kind of design based on a voxel-based system?
Yeah, so actually we had this discussion, and then after thinking a lot, what we decided that the huge factor for this is the AFE units utilizing energy. And this was also discussed in Hypercell, how to optimize the movement of the AFs to conserve energy. But in our case, what we decided is, since it's being a part of the living unit, we decided to make sure that the unit, when not used, sticks to its last location, so that it helps with the other, the human, to control minimum units rather than utilizing all of them at the same time every single day.
Okay, but let's say like this interior that you have there, is that interior transforming over time, depending on different needs?
It completely depends on the human itself. Let's say if he needs like 1 million AFs to create a unit or create a form, the AI transmitter calculates these units, and then it asks the surrounding units, the neighboring units, to the human to come together to form that structure, or it will stay in its last location so that the activity is not disturbed.
Yeah, just adding on to it, to directly answer the question of whether the interiors are transformative, yes, it is. So the furnitures are aggregated according to the needs of the user. And talking on a whole scale of the corpuscle itself being transformative, if we could go to our deployment strategy, it takes the shape of our prefabricated flow plate. So it's not a definitive geometry that this gets. It's the base geometry on top of which this AFA forms. So we can go use it in a cityscape, in a under a not so used building or a semi-constructed building. So it takes shape of the base geometry. So yeah, in that case, yeah, the total system is transformative.
Yeah, because I think it's just like I mean, let's say my constructive comment will be that the way you're kind of designing your spaces is by having a complete form and then voxelizing them, if I'm not mistaken. So you're kind of voxelizing an overall shape. It's not like the system is like self-assembling and building as a bottom-up system. you are doing this in a very top-down manner, which
it's actually both ways. So initially we started with top-down approach, looking at the aesthetics, because even we imagine the final form in our brain, and then we start seeing how it can be created. When we design something like on for architecture, for example. So it started in that way, and then once we have a shape, we start doing topological optimization and see how this form actually becomes a real form. So none of the shapes were actually the ones we decided it to be. It just grew to that shape.
Yeah, no, but like it is more for me, like I think what I found really interesting about like some of the theses in DRL that were kind of like looking into this is the kind of stage where the model is halfway built and kind of halfway transforming into something else. So it's kind of this level of being undefined that kind of like demonstrate that sort of bottom-up intelligence. Whereas like, I mean, you kind of have a different strategy. That's why I was asking. So it's more like you have, you have a form, then topological optimization, and then that top up, like you are voxelizing that basically. Or like you are removing the voxels that are not needed because of the feedback you're getting from the topological optimization. But I think like, just as a thought, like for future, could be quite interesting how you get to the topological optimization, but not by removing, but the way they're kind of like building up. So you kind of get that state in between, which kind of, I don't know, for me, this kind of is almost like, if I know, let's say like, I remember when I went to Lisa Tower or like the Beijing airport at Saha, like I really like it much more when I went to construction site and I could see, all the different stages of construction rather than when I went to the final opening and you will see like the complete finished thing. So it just like makes it quite interesting, especially when you're kind of playing with these voxels. So you kind of go through the stages. And also those voxels, like, I guess like you could also think whether there's a moment that they're more like structural and then some other voxels are have more to do with the kind of finishing rather than like, let's say like the enclosure that you have here, is that still a voxel system or it's something else? So if you go just like one row above, you have there where you have the exoskeleton and then you have the enclosure. So is this the same voxel being transformed or it's like two different entities, let's say?
So the idea is that we have different types of topologies of the AFS based on its needs. Like we also say that the way it's made is different from each other.
Yeah.
For example,
like, I mean, what I'm trying to get here, for instance, is like there is also like if you see like some of the projects, even like I think what Hassel was proposing for Mars, like the idea of like some of these voxels combining and kind of creating like new body types, and then like being able to transform from something structural to something that maybe has to do more with the envelope, and then they can get simplified. So like it can, like you could also have considered a transformation of the voxel types as different things happen. Like I think like you kind of like, I mean, I think just like lack of time, but like the next step for me will be, you define your types. Like the next step would be like almost to give them a life and what happens if this voxel combines with this other voxel, maybe I don't need that other voxel type because there is that level of evolution, both in the voxel itself, so down to the unit, and on the kind of overall. So like, maybe like that evolutionary step, I think like you could have benefit a lot, like kind of questioning a bit more that layer. But yeah, overall, it's super interesting always to talk about these systems. Congrats, guys.
Thanks.
Thanks. Yeah, Alejandro, I think that, that's a valid question of, like just even like showing the transformability or the same amount of, voxels and how they could be deployed like with this logic and system. And like with Hypercell, we were going deep diving into this part, right? Like how the system actually connects on, like a one-to-one level, and then like on, like a bigger levels of complexity and numbers of cells and how they work and how they were hypercells, and because of that, actually, like because they were having the ability to be used also as structural element, but also, like for interior. But I'm happy to see like the differentiation in this project, because I think that like it's going into a direction that like we weren't able to research, and I'm happy like to see like something a little bit different on that side, but also like exactly like showing it also always as a finite state, that it's always frozen, one of the states frozen in time. That's like where like, like we want to see more. What are the other possibilities, like, to do that? And obviously this kind of research is like unlimited, right? Like you can go so much into like deep diver into materiality and what is even new with the technology itself right now, right? Like because things like are getting smaller and smaller, so that means like that maybe your voxel it's like smaller from what we used to work with, right? Like in order to fit all the mechanics inside. So even this kind of understanding, or how do you're deploying them, how you're moving them from one space to another, like even, like it's a different city, like, or even like a life, seeing a life system of how they come together as ants, like in building together, like that's, like one of the fun parts, like also of this type of systems in there.
It's like if you have even in this image that you have here, like, some voxels sort of like forming something else, or like, I would have loved to see how you are blending or morphing one of your vehicles into a corpuscle, like, that kind of migration of the cells, like, would have been quite a beautiful moment to see.
I just want to make a general comment, and I'll make it very quick, because I think it's important to remember when you're facing like a jury or a review panel and you're hearing this, feedback after you've worked so very hard, it's very easy to kind of feel like, oh no, we missed the mark or something like that. But I think the better way to kind of take this kind of feedback and critique is like, okay, what's going to be the next evolutionary step of your project, and how can you push it further? And in fact, some schools I know do preliminary reviews, and they have their important panel before the final review, so that there's a space of a few weeks when you can make a lot of improvements and changes. So I'm really hoping that all the feedback that all of you guys are getting is not being taken as a form of, saying that you missed the mark somehow, or that, you didn't do something well enough, but more like this conversation is an opportunity to go back and kind of continue the research and continue the project. And in fact, I think you're going to find that these projects are going to continue maybe throughout your profession, maybe for the next 20, 30 years in some form. It's surprising how you can come back to early projects that are very spirited and really find nuggets in them over and over again for real projects.
Yeah, actually, there comes my next, the statement. The thing is, personally, it grew so much on me with the idea of voxels and cubes, and it's being the basic unit of building anything that's possible with a human imagination. The idea grew so much that, the next step would be, seeing these comments and seeing how can I make the systems work, maybe analyze the systems more better way, because the lack of time was a huge factor for us to push the results in a very restrictive way, if I can say that. That would be a next step.
Just to add, go ahead.
Okay, you can add, and then.
No, just like obviously, just to add to Daniela's, like they meant this is a very constructive way, and I think like like sometimes just like kind of getting back to your last statement, Manoj. I think like sometimes because everything is possible with the voxels, you kind of need to define what is not possible. I think that's something that happens quite often. If everything is possible, then becomes undefined. And then, you know, like you need to kind of, I think also, you know, the metaverse, or like on this kind of more academic project, like we can define our own rules. And actually by defining the rules becomes more specific, more interesting, more challenging, and more unique. So, but yeah, I mean, it's a, you know, great project. Just like some thoughts in case you want to continue developing.
Definitely.
Thank you.
Thank you. Thanks all for the comments.
I have something.
Sorry, we are almost out of time, and we have, yeah, sorry. Thanks guys for the opportunity to work. It was a very hard journey, and I'm happy that you guys managed to put out a very good project. We should be all proud. Thank you.
Thanks.
And we finally see Manoj's whole face, so that's it.
Probably the fifth time that I am also saying, not more than that.
Yeah. Okay, next team, B5. We have Xinyue and Fatima. Hello.
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 Hello. I'll share my screen.
Share it with sound also. Yeah.
Okay. Hello, everyone. I'm Fatima.
I'm Xinyue.
And today we're presenting the organ print. Throughout the past 9 months, we've been working on developing a theoretical framework driving a series of explorations, utilizing a set of computational tools to address 5 different scales: prosthesis, corpuscle, amalgamation, kinesis, and cosmogony. The expression of identity is always filtered and tailored to showcase a unique side of self. The communication of these identities can be observed across 2 levels. First is by what each individual decide to selectively reveal to dictate how they would like to be identified by others. And the second level is what they decide to conceal. And this is another side of identity that defines who they are. Our exploration focuses on the manifestation of this journey of identity representation and the tension it entails from birth to after death. And because identities are unique to every individual, just like a fingerprint, our system starts with an AI organ, an organ print that lives with an individual throughout their lives, but its presence remains even after they die.
In the life stage, organ print is a tool to express the user's idea. It amplifies interaction and therefore enhances communication. For example, if we use construction-related images as input, organ print will then analyze these data and translate them into physical attributes on any programmable garment. The garment would then become an abstract art piece to showcase what the user wants to show. We're imagining a future where all polymer fabrics carry their ability to be programmed. All layers on garments, such as shell fabric, lining, understructure, trims, threads, will all be able to perform transformation differently. After death, the functional input stops. All data that the organ print processed during life will be kept and later be referenced to inform the development of the post-death prosthesis.
When an individual is dead, the organ print will begin its transformation from a compact device into a fully developed eyes as prosthesis for the living to use. A fully developed prosthesis, the eyes, is an AI reading device that has 2 functions that can be examined when looking into the eye and looking through the eyes. When looking through the eye, the first function is to provide an AI immersive reading experience for the living. The stored memories of the dead will bleed into the realities of the living, altering their perception of a place and time. The second function, when looking into the eye, is the perceived deformation of the new host space, representing the possible change in identity of the living as informed by this experience. The different parts of the prosthesis, including its internal skeleton and external components, are used to support its structure and function. The previous memories and experiences of the dead will now find their way back to intervene and influence the living. And as a result of this layered perception, new places will now become familiar. New faces as well will become familiar by reliving memories that belongs to the dead.
Organ print on prosthesis level is a device that creates and records a person's immersive experience in life, and it continues to develop and projects new realities after this.
At a corpuscle scale, our aim is to create a system where both death and life corpuscles coexist to allow for new types of interaction and possibilities to exist between these two entities.
The coexistence of the corpuscles of the living and the dead shares a set of consistent elements. It's the unit, framework, and cluster with different design languages. The life corpuscle adopts a rigid and artificial scaffolding language representing the construction process itself. Also demonstrate how the units can be connected to create different spaces, such as study rooms, living rooms, pathway, and terraces. The glass material also freed the building from its structure and thus leaves possibility for creativity.
The same set of consistent elements are created to develop a logic that dictates the formation of the death corpuscle, a base unit supported by a framework that guides the formation of the cluster. The corpuscle of the dead is an AI grave that represents serenity in its external shell with layered patterns that can only be read once inside the grave. Each grave is an occupiable space with a semi-translucent outer shell that only provides hints of the internal pattern without revealing its entirety. These patterns are secrets of the dead that are encrypted in the walls of its grave to only be decrypted by the prosthesis. As the grave develops its own intelligence, it will aim at protecting its encrypted data by hacking into other graves to build more layers to bury the original layer of information. Each corpuscle cluster consists of 3 AI graves that interlocks and connects through the binding framework to create the cluster. The interior of each AI grave houses the prosthesis to incubate its transformation in its burial site. The interlock between the graves is meant to create these in-between spaces to allow corpuscles to weave and interlock with each other.
In this level, organ print creates a space where the living and the dead interact with themselves and each other.
The tension between life and death continues to be exhibited at an amalgamation scale. The aggregation forms vertically, where life corpuscle would inherently aggregate from the ground up, allowing post-death corpuscles to aggregate from the top down. Both amalgamations meet in the middle to create pockets of communal public areas where the living and the dead can share experiences, exchange stories, and reveal secrets.
The height of the aggregation is determined by population density and the death rate of the area. Life amalgamation is created in 2 steps. First, part 1 aggregation takes place by the full or partial occupation of the parallel pipes, which will in turn offer a new variety of formations. Second, part 2 aggregation builds upon the different corpuscles created in part 1 to build large-scale amalgamations. An additional factor is applied. The higher the unit grows, the more it resembles the death corpuscle. Here's the build-up sequence. And we apply the same role to the site, and then we have organ print life city. Organ print life amalgamation is fundamentally interested in how a body physically experiences space. This is a full look at the city where you can see more details of the stairs, bridge, balcony, etc.
For death amalgamation, a vertical binding element is introduced to allow AI grave components to be aggregated vertically and branched laterally through a specific set of connection points. The result is an aggregated pillar, a cemetery library of AI graves. The aggregation is in an ever state of growth and expansion. Here is the build-up sequence starting from the initial stages of the aggregation, where it would aggregate and branch downwards to meet with the life amalgamation at a developed stage. The aggregation logic has the ability to guide the formation to spiral vertically, allowing for an accessible hollow core to be used as a navigation spine along the pillar. This view shows both amalgamations meet in the middle to create pockets for the public spaces. And here is a zoomed in view in one of those communal spaces. The full formation could potentially branch further to generate woven network of cemetery structures. The simultaneous coexistence of life and death amalgamations will be challenged by the desire to dominate and fight for security and permanence that is threatened by each other's existence.
The kinesis scale aims to create a network system that facilitates the navigation between both sets of amalgamations. As the amalgamation grows in height to better connect stock throughout, organ print life develop an elevator that moves vertically and horizontally following magnetic tracks. Similar to prosthesis transformable technology, the organ print elevator is also transformable to enhance flexibility when moving and parking. Here's the scenic view with the elevator and the city's residents. And here you can see the kinesis live public transport system blends into the city landscape. It provides a smooth transition throughout all levels and branches out its tracks as it goes higher into the private death realm.
The verticality of the death amalgamation inherently forces a vertical network system that allow for vehicles to navigate around and through the pockets of the aggregation. The points of a clustering becomes the focal locations for the network to expand laterally, creating a series of network clouds along the pillar. Since the pillar of the death amalgamation contains multiple clusters at different heights, the resulting system is a layered cloud system that allow for connections in both directions. The vehicle of the dead is a private vessel that allows passengers to travel up from the structures of the living to the AI cemetery formations. The vehicle consists of 5 main parts: a primary wheel, a secondary wheel, 2 compartments, and the external binding frame. The pivoting of the wheels control the direction, rotation, and speed of the vehicle to move in correspondence to the network. For accessibility, the lower compartment slides over the upper compartment to reveal the opening for passengers to access the vehicle. And this is a view of the combined network system at a kinesis scale.
The cosmogony network witnessed the change on our urban scale. Using Florida as the site, we take the existing urban areas as the anchor points and moving them following the inward projection to create boundary lines.
We have identified areas where cemeteries are located and overlap with the locations of cellular radio towers. The resulting clusters will become the main area where amalgamation towers will be located. The first step towards developing our system is the formation of the major routes around those identified clusters. And in the second level, you can see both the medium and the minor routes emerge to connect the smaller areas. At a third level, we can see how both life and death starting to form their own emerging networks where they interact together and form this interweaving system around the bigger clusters as well as the amalgamation towers. Lastly, the resulting public spaces could then be generated in the areas in between those networks.
The interaction of amalgamation within the site can happen in forms of any of these conditions, where one system could take place inside of the other or transition from one to the other. Replaced by the simplified amalgamations, these conditions are a representation of the relationship between life and death as manifested in the scale. Here's a close-up of our map where you can see the life and death amalgamation with their public areas and networks.
This is the Cosmoprint that consists of two main interweaving networks that facilitate the connection between amalgamation elements and their distribution within the site. In our world, we are providing the living with the means to connect, learn, and interact with the dead to create a better world where the physical death is only the beginning of an eternal virtual life.
Now let us show you a peek of our words in action. Thank you.
Very impressive.
Thank you so much. Amazing project. One of my favorite concepts during this year.
Thank you.
Thank you very much.
Yeah, maybe I'll just say a few words very quick. Yeah, no, I just like I think like for us, like when we were doing the second chapter together, I always enjoy this dualism between, like, you know, like you have a very strong framework, like theoretical framework, and then the dualism, and then the kind of discussions we had about like how, you know, like the living and the dead, like how when we were kind of growing the system, we had these communal areas, and then like the kind of whole tension between the two things and the whole kind of symbiosis between the two systems. I think that that's been beautifully developed over the next chapter. Just want to congratulate you for that. Good job.
Thank you.
Thank you.
Thank you. Appreciate it.
Yeah. Hi guys. Beautiful work. Really enjoyed all the stunning visuals. I think I really like the concept, and I think it is very very close to the debate around storing consciousness and like letting the consciousness live for a longer time. And I think like just looking at your presentation, I started thinking about the amount of data that we already generate, and the amount of data that in your project you are trying to retain. So basically, everyone who dies, the data, like their data is getting lost in some ways, and you're trying to retain that data as much as possible. And I was just Googling about the amount of storage space required to and the amount of data that we are generating. I think it's like it's around by 2025 we are going to generate around 175 zettabyte of data, and the current biggest scale data center is about 10.7 million square feet. So I think it's quite interesting to think about the amount of space that we would need in terms of when we are thinking about this large scale storage of data and storage and access of data. So but in terms of your projects and the visuals and your presentation, it's wonderful. I enjoyed your project.
Yeah, thank you very much. Yeah, this is definitely, I think, a good question. And this is something that we also started to kind of research and investigate in a cosmogony level, like where to place those cemeteries and what would be the ideal placements for those pillars, so that being data centers themselves, what would be the ideal scenario? And I guess this is where it came up in the conversation. And I guess there's also, definitely, I agree, there's a lot of potential in thinking about how that could be deployed, and even when it comes to the storage space and how we can use it and where and all of that. So yeah.
Yeah, your project is really amazing visually, and also, I mean, I appreciate how you set up your presentation in a very dialectical manner, really focusing on these opposites of life and death. But what I was thinking is that there is also kind of a continuum where you have things like cryonic suspension. You have people that are losing their memories while they're still alive, like in Alzheimer's. And I'm wondering how this project might be investigated in a direction where one can create a repository of their memories while they're still living, for kind of a playback. And what's interesting in Alzheimer's specifically is that a lot of times people who have really basically, they don't recognize anybody or anything anymore. Their memories can be reactivated with things like music. Like there's a beautiful video out there of a prima ballerina from Russia who was very advanced in Alzheimer's, and they were playing this music for her, something that she performed many times. And she literally started to perform the movements with her arms, and it was just a very beautiful thing to see her coming alive. So this idea that we're always in the process of dying and we're always in the process of losing certain things as we age, I think I would love to see this project kind of get enriched with like other investigations like that.
Yeah, definitely, I agree. I guess, yeah, this also goes back to the question of what does it mean? When do we die, actually? Is it the physical death, or is it more about, losing control over those memories that we have? So I guess there is definitely, I agree, a great potential of trying to investigate in that direction as well.
I just want to congratulate you as well. I think it's a really interesting and very unique project. I think the subject matter is also quite sensitive, which I kind of can appreciate as an amazing choice for you to kind of tackle it. I was wondering if you could speak a little bit more about your motivations behind why you chose the subject matter, if that's something that you would like to answer, because I think that there's like the implications of what you're suggesting are quite amazing, I think, for a society, for like a community of people kind of recognizing this endless cycle of life and death and how that influences us. Because especially in, let's say, Western society, there's this very harsh divide between the life that we lead, and even the way that we kind of structure, let's say, cemeteries or funeral homes are always seen as very separate to our own urban environments. They're seen as something that's almost hidden, and people don't like to discuss it. Whereas it feels in your project, you're kind of really trying to tap into the potential of what this would mean. So I'm thinking, just as a question to you, what was it that sort of put this forward for you as a team, thinking about these issues and how you wanted to address them?
Yeah, I think I'm gonna maybe answer and then also pass it on to Xinyue to also add. But I think one of the things that I guess we discussed earlier when we started to work on the project is we have a lot of this huge amount of information that we are generating, that we're producing and we're creating, and also tracking. There has to be some sort of passing of that knowledge as well. And the passing of knowledge right now is really kind of limited to what is being, to the venue and to the medium that we have right now. What if we extend that that vessel, let's say, of transferring knowledge to someone who might not be there, and trying to get through different layers of knowledge, I would say, of getting to know more about who we are, about who are, as people, and who is it that we're interacting with in general. Yeah, I guess that's one of the things that triggered us into getting through that. So yeah, I don't know, Xinyue, you wanna?
Yeah, I agree with what Fatima said, and we just wanted to look into, to see an option, what would be like when we bring the deaths back to our life, and how this communication will change from a human scale to a larger scale.
Thank you. And again, an amazing project, really well done.
Thank you. Appreciate it.
Thank you. Thanks, girls. Any last comments? Thank you. Thank you, girls, for the journey.
Thank you.
Thank you for the work.
Appreciate it.
What an amazing concept and project, and I'm glad that we managed really to pull it off super high quality, and looking forward to what's next for you.
Thank you very much. Appreciate it.
Thank you.
Okay. Next team, we have B4. Julieta.
Hello. Can you hear me?
Yes.
And see me?
Yes.
Okay, let me share the screen. 1 second. Okay, I think I'm sharing my entire screen, so we should be fine. Okay, my name is Julieta. Some of you may know me from before. So let me walk you through all the work we have done in these 9 months of the master throughout the different chapters. Which is, I have it back. So we started with the first chapter. Then the project I'm working on, it's new species, is the evolution of the humankind into this new species. So the first chapter was all about the prosthesis and all the different softwares. I was very new to Maya and pretty much a lot of the software here, the majority of them. So it has been quite a journey in the learning process. Then the corpuscles as well. It was more into grasshopper for different patterns, rhino, and so also some new techniques for renderings and key shots and different renderings aspect. Amalgamation was a nice journey for me because it was more deep into parametric with grasshopper and just using different functions and different plugins. So that was great. And kinesis also, for me, a great discovery in this chapter was Houdini, which I'm amazed and I can't wait to start using in different aspects and projects. And then later on, also a bit more of grasshopper and different techniques as well for representations. So, sorry, not that one. So let me take you now to the actual presentation. 1 second. I had it in presentation before. So it's a little bit slow, my mirror, so bear with me. Let's just. I don't know if it's my camera with the connection or so. So let me take my camera off for just a second so I can see it's my connection.
Sure.
Yeah. Okay, here we go. Okay. So new species. New species is the evolution, as I said before, of the humankind into this new species. And from the evolution of the universe, all living organisms and everything we experience are a result of profound asymmetry, and collective intelligence connect in different directions, in different dimensions. It's assumed that the contemporary human can only interact with 3 dimensions, or 4 if we include time. But every relationship with our surroundings is still three-dimensional, how we perceive it, design, and interact with it. Some species will also interact with these dimensions based in different physical forces, like magnetic fields, for instance. Such a species has been evolving and adapting to these forces throughout their evolution. You know, sea turtles, birds, fish. Even some research says that animals could interact through magnetic fields from other magnetic fields generated from different animals even. So as human, we evolved, we have started to operate with some collective intelligence as a society. The specific community is making, the scientific community is making constant progress in understanding and learning from all swarm intelligence behavior manifested by other species. As we keep evolving with exponential programs inherited from collective intelligence enhanced by AI, constantly learning from different species, understanding and mimicking their relationship and connection with all the dimensions we exist in, from a single cellular species to the cosmos level in an adaptive and evolutive way, the humankind is soon to evolve to new species. Therefore, if we can use the collective intelligence from the cosmos level to a single cellular species in a symbiotic way where the species can learn from each other, a coherent species will be the genesis, maintaining the balance of the system of synergies in all dimensions. And we will evolve to be this new species, not also in the physical aspect, but also in how we behave with the environment. Our body will change to have 3 main components, where we will have the intake of data from the environment and learning from different species connected through the spine that will allow us to perform different tasks and take this through our entire body. We'll start showing 3 main characteristics as the skin, performative skins, the energy channels throughout our bodies, and also micro units in specific regions of our bodies that will also provide power and this ability to reinterpret and re-evolve based on what we have learned from different species and the environment itself. As the graphic of these 3 components, you will see the main item, the spine and the connectors, the energy channel throughout the bodies, and also the performative skin. In the way this works, we will do the data intake, also the energy data flow. The performative skin will help us to also intake more oxygen and energy as well, and keep our body full energized and be efficient and have this power intake. So these main 3 components you see in our new human body will be established in all process of design as we evolve. The energy source storage, the connection channels for data and energy, the energy distribution channels throughout, and the performative skin just for better adaptation. The evolution of the humankind into new species will take us to sustainable societies extremely interconnected from a cellular level to the cosmos level in a perfect and constant balance. The human and its development will act as a system that can learn, adapt, and perform in space and time, energetically synchronizes with their entire habitat and cosmos. As we will start evolving from natural forces, learning from all these species, One way will be to be related to the magnetic fields, for instance. So as we plan for the neopod, the house for this species will be in perfect relationship with the natural forces adapting to the design fields and magnetic response of the site. So for this type of concept, the design will be very organic. We'll have part for us to rest, part that will be extreme connection to the site and the energy anchor, and also the energy distribution throughout the house. In a more detailed section of this neo-residence or neopod, you will see the resting areas, the performative areas, the energy main point of connections and rebalance of the entire system, and then how all this energy gets transferred to the entire house. In more detail, these elements you will start to see, it's the main energy cores, which will be the anchor to the site energy and the force, and this will later allow us to anchor to different units and grow as a city, and also to be more interactive with each other in terms of the magnetic field. The performative scheme could change size, colors, and also the aperture in order to be more efficient and be more adaptive to the site, and whichever is the new site we could conquer in a way. Also, different areas in a straight relationship with this core will be the open performing area of this residence, which completely opposites for the resting and enclosed areas. This will allow for the humankind to start learning and teaching each other as well what they'll perform. The energy channels throughout the pod, you will see it's entirely covering the upper part, the lower part, all the units. So it's always balanced and always with this magnetic field and balance energy in the house. As this core energy main spot is the direct connection with the site, but also it keeps the human in balance and the entire house in balance, not only energetically, but also connected to the cosmos level. The same more of the detail of this interior-exterior area, and also how it could start relating, for instance, maybe not to just the magnetic fields, but also some forces that could come from tidals, for instance. As we grow a city, the amalgamation would count with different areas. For instance, the house could grow in double the size in terms of stories and also 4 times the amount of units. Each core will have a connector closer to the energy center, and also this will allow later on to vertically connect or horizontally connect, transferring all this energy. Towers will start appearing to give more breeze to the city and also being the main energy source and distraction source for environment, for the new species to interact. You will see some images of the city now, and this when they grow in towers or horizontally. More details about the city, how each tower has maybe 1 or 2 main energy sources, same as the previous unit, the home was. There are different energies that will start transferring energy through the entire city, and then it will be not related to the natural source, energy source of the site any longer, but it could establishing our sustainable growth of the city. Another image of how this energy core of this tower will interact with the entire environment, and also the different units and the different new species inhabitant that lives in that towers or in that area. As part of the transportation, new species could move in private transportation. With this type of vehicle, will always have the same 3 characters of the evolution of our body type, the performative skin, and also the energy distribution channels for the distribution of the energy. Also, it will have the energy core power source and the magnetic connector, which will allow this to anchor to the route, anchor to the parking station, and also anchor itself to the human or to the neo-species body that it's driving it. As part of the public transportation, it will be the capacity of about like 50 neo-species, 50 person or more. It will be also magnetically connected to the main route, and will be a back and forth of energy between the energy and the people itself inside the bus and also on the system. You will see the energy distribution channels throughout the structure of the bus as well. Just a section showing where we have the power and the main connector areas throughout the unit, and also an upper link to the main system ports of energy. Another image of the city and the tower and how the cars could magnetically start contributing in energy from the car to the parking and vice versa to the tower. Okay, about that. So the three main components of the parking area, and also as how we grow in terms of the city, we could be related to magnetic force, but also to tidal, for instance, whatever could provide us energy. So in this case, the city will start growing from the water energy into the land, and then we will start taking different energy, as I was explaining, to be able to generate the city, but then the city could grow. Open spaces will be crucial for us to just do a deep balance and intake that evolution and keep evolving to a new to the next chapter of this new species. These are more details of this city. And then nature is a source of all nature knowledge. She has no effect without cause, nor invention without necessity, as Leonardo da Vinci said once. So we have evolved from our physical to our mental state of mind in order to be prepared to always survive as the best species, adapting from different species. And also producing like all magnetic source, now we will be able to grow to different stage, independent and as a sustainable city. So now I can take you to the video where you will see all these in a better glance. Give me 1 second. Let me know if the audio is okay, because I'm just sharing my screen.
You should share audio also.
Is that from?
It's from Zoom.
Okay, give me 1 second. Sorry, and that is, do you know where that option is?
It should be.
Share. There, I found it.
Yeah, okay, thank you.
Okay, sorry. So here we go. So that's as far as the video and the presentation. So let me know if you have any questions or comments.
Thank you. Thank you, Julieta. Wonderful. Like everything came together wonderfully in the presentation, and all the visuals like were cohesive. So I'm happy to see that. It's the only comment I have like for this project actually is that I think that like there was a missed opportunity a little bit on the level of the core puzzle itself, the living units, because like they were all a little bit like over designed. And I think that like then the aggregation level was like, you know, like more challenging to navigate, and it had a lot of information that was holding from the corpuscle level. So yeah, like, you know, if there was one comment like that I would think, I think that that was like a moment that like, you know, there is an opportunity, you know, like to rethink that point in the presentation. But I am also interested to see like what are your thoughts, and also like what inspired you like to go into this project and this specific topic.
So in the beginning, the topic we were preparing with another partner, and it was all about the evolution. It was great to start exploring how different species keep evolving, and also, you know, what we have a significant time in the evolution. We are just a minimal time frequency, but we have been part of it. And it's great to start thinking how we will evolve with all this technology we have. Also not in, you know, AI, but also physically in a way. So we start thinking, you know, what characteristics we could have taken from different species, and how will that be a better behavior or a better idea to a new city and to new relationships even between each other in a way.
Yeah.
Can I interject a bit?
Of course, welcome, Gabriel.
Yeah, thank you. Hi, Julieta. I love your project, particularly for the fact that it kind of touches in a more comprehensive way, the urban aspect of this exercise. So you are creating systems that start relating with the topography, which I think is great. They are not just like simple floating systems that are being attached to a neutral background. And also you are creating spaces that tend to be more urban spaces, which again, I think it's a great quality of your project. You're also playing with the in and out of these spaces. Morphologically, I think you're creating complex systems that have hierarchies, which again, I think it's great when you start conceiving a city. You don't just have some repetitive clusters that show up in your design. So you have different shapes that cater for different functions, which I think is great as well. And I think that's a great take on your exercise. So congratulations for it. I love it a lot.
Thanks. I think, sorry, go ahead.
No, go right ahead. Go ahead.
No, I was going to say it was important in the exercise of design, and also as we evolve, having all this, you know, data, energy, and also, but having this mute space, you know, and that has contributed also to the urban fabric. Just being able to have these moments of process in a way, and intake and balance, and connect again to the entire cosmos in a way, in theory.
Yeah, I think it succeeds on that. I think it's very.
Yeah, I mean, really, first of all, congratulations on how beautiful this project is, and also I too find it spatially and urbanistically credible. I'm one of the people that really buys into the theoretical underpinnings of parametricism and its current permutation of tectonism, where the idea is that fluidity and curvilinearity kind of cohere extreme complexities and make it possible to kind of digest and read the environment, the built environment. You know, a lot of things that are being developed in the metaverse really aligned with parametricism and really kind of push it forward in very surprising ways. That are a departure from like some of the early experiments in parametricism. So I really appreciated that. And I also, when you were talking about nature, I was kind of wondering how you define nature. So I guess I'm going to ask you that question, but I also liked the idea of our physical, mental evolution kind of attempting to survive for a longer period of time, or kind of surpassing the boundaries that we currently have. So, I mean, a lot of times in critiques, I like, especially with people that design parametrically, there's always a discussion about nature. And I think it's important to define what that is, because I think actually it means kind of a second nature or an artificial nature. So how do you view that aspect of your project?
So, you know, when we were exploring this topic, I ran into this phrase of Leonardo da Vinci that says like, nature is the source of all true knowledge and has no effect without cause, nor invention without necessity. And, you know, it's not only the shape or how things start growing, but for instance, in this particular project, like the station has been inspired by how the bees transfer energy. And they're using that concept also for the electric cars now in a way, and how everything could be part of like a bigger system, you know? So it's amazing really all the guidance we have out there and the perfect balance all this has really. So I guess I will answer your question using that phrase in a way, and how we could really, with the right amount of balance and taking the different components of nature, we could really create everything again. You know, it's like this source of tools for us to reinterpret the world or so. So I think nature is just a great guidance, and it's just the framework for everything as well.
Although there's an interesting thing going on right now in physics, a kind of massive debate and also late developments that are kind of redefining the fundamentals of physics and are actually departing from this idea of space-time. And there's also a philosopher who's a scientist that talks about the fact that anything that we perceive has nothing to do with what can be called reality, that everything we think and everything that we see especially is kind of in a very limited range of interpreting something that may be out there. So this is kind of a continuing discussion. What is nature? What is it that we're capable of perceiving? How we mathematize our understanding of physics. And what's being discovered right now in physics is that if you strip away this idea of space-time, the equations come much closer to things that are observable, and they become also much simpler, because right now in order to calculate space-time things, you have to kind of go through many, many cycles of iterating like smaller particle ideas. But when you apply this kind of newer conception, the newer mathematics around physics, that's no longer necessary. So I think the question of nature and whether we are in fact capable of perceiving anything about nature is a very interesting thing. And I think the way that you tackled it is also extremely interesting. And obviously your project is just amazing. So congratulations.
Thanks. I sorry to add, but you know, reading through some papers also on understanding how many dimensions we could have, and you know, they say like 4 are the ones we can kind of like understand, but there may be 11 more or 11 in total that we don't even get to understand just yet, or at least, you know, me reading the papers, I didn't get to understand them all or how they work, but it's this, and it's this nature. But then I feel like when you start putting the conscious on that, I feel it's when energy really has like a key point, because you may not be aware of a lot of stuff, but I feel there is always like this conscious energy connection to whatever minimal structure in the cosmos is. Like, I really believe in energy in that way. So hopefully at some point, even if it is different dimensions, different time, different scales, we could always have this link of consciousness in order to help us understand and relate to them, and even to relate to each other in a way.
Okay, thank you everybody. Thanks for the comments. Are there any other comments? Okay. Julieta, thanks for all the work. You remember, like she was a one-man team from the almost the very start. So congratulations on like you actually managed to finish everything. So that's a special ability.
It has been a long journey.
Yeah, it was a crazy journey. And thank you for all the work you've done.
Thank you, and thank you really for everyone for the time and the patience as well. I know my schedule hasn't been the best, but it has it has been great to learn from all of you guys. So thank you for the opportunity as well.
Thank you. Okay, so we're gonna take a 10-minute break and we come back to team number. Okay, yeah, so we can come back to team number somewhere later. Something, yes.
Perfect. Thank you.
Thank you. Okay, let's continue. B8. Dean and Paco. Okay, let's wait for Dean.
Hello.
Hello.
Sorry for the delay.
Okay, yeah, you can start.
Okay. Hello, my name is Dean Collins and my background is in fashion design.
Hello, my name is Francisco Nassar. I am an architect and a restorative yoga teacher.
And together we have been developing our thesis project, Restorative Homeostasis.
Over the course of this program, we've been able to push ourselves to grow as designers, and we're excited to share with you the product of 9 months of work.
We will be showing our project to you in reverse to show you the timeline of our project and to see how the macro scale has emerged from the micro. Restorative homeostasis started with our identification of stress as a growing problem affecting the global population. Stress levels have been on a consistent rise since the late 90s in correlation with the extreme growth of interconnectivity and access to the internet, and a growth in awareness of existential problems such as climate change. Over the past 2 years, an even greater spike of stress levels was observed as a product of the shutdown and uncertainty following the global spread of COVID-19. To help us address the problem, we began by identifying 3 key types and scales of stress. The types being physical, environmental, and emotional, and the scales being individual, collective, and global.
In order to combat stress, we began research into traditional and contemporary remedies. It was through this investigation that we learned more about the human body's pressure points and the meridian lines that connect them. Adapting this area of research, we developed our formula for design thinking, identification of key pressure point sites within the system, and tailor meridian lines to them. This allowed us to develop the system's efficiency and interconnectivity. It is this formula that forms the foundation across all the design scales and principles and disciplines addressed throughout the course of this project.
It's on the cosmogony scale that we address stress on a global scale and envisioned a multi-layer pattern of different flow lines. These layers provide new connections between the different neighborhoods and surrounding areas of Chicago, thus changing the relationship between them. Stress reduction was addressed through an emphasis on efficiency and sustainable transportation. Using data maps collected through our research of the city, we were able to recognize stressors in 4 primary categories: environmental stressors, exposure to physical factors, exposure to biological factors, and technological hazards. These categories allowed us to identify key sites of stress around which we focused our design. One current source of stress for the city is environmental change. The rise of Lake Michigan's water levels and an increase in precipitation has caused floods, beach erosion, and infrastructure damage.
In order to combat these harmful effects of climate change, we looked to the waterways as a means of relief for water runoff and more efficient water level management. Expanding these waterways provided further opportunities to blend the current urban landscape with a greater natural presence and a means of alternative water-based transportation. To further develop the urban organization, we reimagined the road network using a break-the-grid mentality, reshaping the city block into organic arrangements at identified critical stress points. Using the negative spaces left by the new roadmap, our amalgamation can then be placed to populate new neighborhoods that are the product of reworking the city.
As a means of transportation around our amalgamation, we developed a public and private network system, each addressing stress in their own way.
The 9 nodes that our public transportation system was developed with aim to connect pedestrian and bike paths on either side of the amalgamation, with 3 interior sites identified as likely to receive the most traffic. The design of the private network aimed to provide more direct connections to specific units within our amalgamation through the design of a road network.
The public system we envisioned would run on renewable electric energy and to reduce emissions and sound pollution within the amalgamation. In this system, we also explored the theoretical application of an artificial slope for the movement mechanism.
The private transportation structure connects the community more intricately by combining 3 primary levels of road for more direct movement through the amalgamation. Together with tunnels built into the base structure of our amalgamation, they make up the total of the private network. It is also these base structure tunnels that the private stop and storage units are located. The private transportation vehicles are designed to accommodate 1 or 2 people and be man-powered while still being autonomous. These transportation capsules will be encased in an organic bubble reminiscent of our corpuscle design, while its soft interior will work as an inflatable system, providing different furniture shapes and space allocations as needed by the users.
Our public transportation car compartments took on an organic shape with 2 extensions for entrance on one side and exit on the other. This layout was to control the efficient flow of users in and out, and around this entrance and exit system, the layout shape of our stops was formed. These organic in shape echo the compartment designs and provide 2 platforms, one for entrance and one for exit. For the design of our amalgamation, we began with a key idea to link 2 existing city parks. We centered our design around 5 main principles: safety and comfort, lifestyle promotion, access to green and natural areas, inclusivity, and environmental integrity. Our amalgamation layout was formed around the identification of 3 key points in each park and the optimal flow lines that we formed between them. First, a base structure was produced as the frame for our structure, upon which 5 aggregation programs were developed, using different rules for connection and corpuscle unit variants.
Each program within our amalgamation provides a different function and opportunity for community and activity and engagement. The housing program finds an optimal organization for inhabitants' privacy while sharing access to the 2 parks. The spa provides a site for guided, immediate, meditative, and active stress relief. The Yacht Club serves as a meeting place to unite people with a shared appreciation for water sport and the lake environment. The design and the organization of the public spaces we used as an opportunity to extend the existing parks onto our amalgamation, providing an open air natural space.
When beginning our corpuscle chapter, we researched into 3 categories of ergonomics: physical, cognitive, and organizational. Area usage became the definition of pressure points, while the spatial flow that would unite them, the meridian lines. Using the spatial plan we developed, we pushed our form into a multi-layer base, which served as our primary structural component for the unit. Here we theorize the potential application of carbon capture technology as a means of construction. Inspired by research into the biological functions of coral, we saw their formation of skeletal composites through seawater filtration for calcium as a model for a carbon capture air filtration construction technique.
This technology, we imagined, would prove particularly successful in urban cities that produce roughly 78% of carbon emissions and substantial airborne pollutants that adversely affect over 50% of the world's population living in them. Our carbon formation could then grow around the predetermined negative spaces from our previous design explorations, improving air quality and providing structure simultaneously.
When moving to furniture and interior design for our unit, we saw an opportunity for the application of inflatable architecture. Inspired by CAD cam knitting, we began to consider the way we would use inflatable furniture to morph spatial function and flow.
These furniture integrations played a role in determining layout of rooms and the uses of subspaces. This dynamic aspect of the furniture inflations means that the spaces can be altered as needed by the inhabitants, providing more efficiency and spatial adaptability.
For the scale of the individual, in our prosthesis chapter, we used our research on pressure points in the human body and the meridian lines to shape our design. Stress is an emotional and physiological reaction that focuses the body's energy on select functions. This channels energy into unnecessary areas of the body, resulting in an inefficient system. These imbalances can hinder critical thought processes and create muscle tensions that can cause negative health conditions such as scoliosis.
Our designed wearable aims to release these muscle tensions and aid against poor alignment, breathing, and muscle issues. Utilizing the body's meridian lines, a frame was created that divides the wearable into 5 categories. The massage section covers most of the back's muscular area. When stress levels rise, sensors monitoring the biochemicals present in the water sweat trigger the tubular pockets to inflate, applying pressure to the muscular groups. The compression section, which covers part of the chest, is designed to morph, guiding a specific breathing pattern depending on stress readings of sweat and monitored breath rate.
Heat and ventilation areas are applied on the wearable to help regulate body temperature for comfort and muscle relaxation and repair. On the hips and along the legs, we have designed a support piece that aligns the hips while microbending the knees to keep a good posture and protect the joints. Collectively, all of these chapters have come together to form our project, Restorative Homeostasis, and we hope that you will enjoy the short video we've made showing these chapters in action.
Right now, the real work you have to do is in the privacy of your own heart. All of the external forms are lovely, but the real work is your inner connection. Just quiet your mind. Open your heart. Quiet the mind. Open. that which you can love and just keep expanding it. You love a tree, you love a river, you love a leaf, you love a flower, you love a cat, you love a human. But go deeper and deeper into that love.
Thank you.
Thank you, guys. Congratulations. Amazing project, really strong one. And the video is very, very powerful. Congratulations and thank you so much.
Thank you.
Thank you.
You really took us to this space. Oh, sorry, Ada, for cutting you off.
No worries. Yeah, I just want to say that, wow, like I really feel so much more relaxed right now. It's like it really did something different than only the presentation alone. And to be honest, like I love your project, but I am not really the biggest fan of the colors. But in this video, like connecting to nature in this way was really, then now I understand the colors as well. So thank you for improving that.
Thank you.
I think, yeah, definitely it's one of the, what I'm excited about in this project is that it reflects you both in a way, like you brought in very much of who you are, your backgrounds, your interests, what you love into it, right? Like fashion design, and then anything that has to do again, like with the human body and how, you know, like to actually de-stress, how to actually like meditate, like, you know, make things better for it. And I think that it's a project that it's easy to be appreciated because we can all relate to this, right? Like to this need for connection with nature, and also, you know, like it's just amazing, like all the levels that you took. And I'm happy also that like you reverted the flow, right, like of your presentation in order like to go from the bigger scale to the smaller. And I think it worked fabulously, like to see it in this way too. And the only comment I would have is that like I think that there is room for improvement, because like the bodysuit you created, it's, you know, like it's tackling absolutely everything that, you know, might need to be tackled, but maybe it's not needed all at the same time. So maybe all these layers, you know, like the same way that you'd go to the gym and, you know, work your legs for one day, the other day, like other part of your muscles. Same thing with massage, right? Like, and like any kind of like therapy, you want to segregate that. And I understand that in your bodysuit, they might not be working all at once, right? But the thing is that like still like having other opportunities, even from the interior or the furniture, right? Like to play this role. And I think that you incorporated some of these ideas, but then like, I think that it would be interesting to see the furniture as an extension of the bodysuit, and the bodysuit being like an extension of the interior and then exterior, right? So I think that there are like some really powerful ideas that can be also like, you know, looked into. But again, like we need to keep in mind that's 9 months. You guys like did an incredible job. It's like, it's amazing. You know, all the projects, like I know that like exactly like what Daniel was saying before, like, right, like these are just ideas and things that like we think about while we're looking at your projects. But I think that like you guys did an incredible job. Yeah, thank you.
Thank you. But yeah, I think you touch on some good points. I mean, we started this project like bonding over the things that we had interest in. Both of us wanted to explore designs that felt a little more like connected to like everyday use or everyday people's experiences. And Paco has a big interest in yoga, and I like to spend time outside. So we kind of mashed those two together, and this is what came out. But, you know, I think the basis of this project is something that we could continually revisit and improve. And, you know, even today, if I were to go back and explore the prosthesis chapter again. I think every time I would revisit that prompt, I would probably make something different just because there's so many different ways to approach it. So,
okay.
Yeah.
Any other comments?
Well, just to say big congratulations, and I ditto a lot of things that was said about your project already. And also I want to express again how amazing it is. What all the students achieved in 9 months is just really, truly incredible. So keep going, guys. And I hope all of you can show at the Chicago Architecture Biennial next year. I will organize a big event for you guys. And you're all invited to broadcast your projects again.
Okay, thank you so much.
Thank you, thank you. Thanks for the opportunity.
Yeah,
Oh.
Thank you everyone for the time and all the opportunity to make this project. So thank you.
Yeah, so now you have time to go back and start working again, because you know, Chicago Biennale. It's like no break.
Exactly.
Yeah, I want to thank you for the presentation this time around, because you managed to pull it off, like really up the skill on the way that you presented, not only in terms of the visuals, but also in terms of like narrative and the way that that you were like a lot more confident. So that's a nice way to finish the master. And I was super enjoyed working with you. So thank you.
Thank you. Yeah.
I also, before we move forward, I just want to ask, because like, again, like I know that like being like for you, like it was also like a totally new endeavor, right? Like coming from the fashion design world. I know like Paco, like you had experience like with computational design and with 3D design, like through architecture. But I know that like Dean again, like was like from a totally different field. How did that feel in the beginning? Like a totally, you know, like a new team, new like, you know, skills like coming in, and also like being for you, like learning and going into 3D design in the first place, right? Like that must be, have been like something interesting and when you started the project.
Yeah, I think, yeah, I mean, it's been amazing to, you know, be exposed to this like 3D digital discipline. Before this, everything I did was physical, you know, hand sketching and then leading to like pattern making and sewing stuff. But it's fun to explore this sort of new way that I can approach design thinking and like communicating ideas. So you know, it's been a great opportunity to learn. I think you know, this project, I don't know, it's just amazing to think that, you know, 9 months ago was the first time I ever opened a 3D application. So going from that to this stage, it feels amazing. So I mean, I'm only excited for what's to come, the projects I'll make in the future, and just to continue to contribute to this community. So thank you.
Thank you. Paco, how was it from your perspective?
Yeah, for me, the same. I also learned so much working with Dean, working with different perspectives and merging our ideas. It's been great, and I'm very grateful to spend this time with all of you and all what I've learned. It's been an amazing experience. I'm still like processing, but yeah, I'm excited, and at the same time sad that this is over. So thank you all so much.
Thank you, guys.
Thank you. Thank you so much. Okay, let's move on to the next team. B9, Walter. We have a really nice t-shirt.
Ready. Okay, here we go. My name is Walter Patrick Smith, and I'd like to introduce you to the idea of the age of the autotroph and kind of a vision of autotroph technology provides access to a productive zeitgeist, reminding us that the abundant clean air and food that are essential for all life on Earth and bountiful source of renewable innovation in our future. Every day for the past 4.543 billion years, the Earth receives enough energy to power everything that we know more than 10,000 times. The big user of most of that energy is autotrophs. The very earliest autotroph appeared on Earth 2 billion years ago. It was a cyanobacteria. What autotrophs are producers. They're plants or bacteria or algae that can produce their own food using photosynthesis and chemosynthesis. So in this chapter, actually for my thesis, I've considered photosynthesis one of the purest of technologies that we've ever experienced. Plant cells, and I've really spent a huge amount of my time during the master's in the fundamentals of plant physiology, only to decide that really we've had a lot of ages on Earth. Most of them are compacted into the last 300 years. But the one that is most interesting is this renewed interest in nature. And perhaps this renewed interest in nature came about in 1965 with kind of the flower power movement that happened in the United States and spread worldwide. So that's a brief introduction. I have a protagonist that I'm going to call Mogi. Mogi has the ability to talk to plants. We received an order of epiphytes from Amazon. In the order was Plant Wave. We'd been studying cymatics. And lo and behold, combining those three, we started to be able to have a real-time dialogue with plants and started to learn how much billions of years of technology plants had and maybe were ready to communicate with us. So here we have Mogi, and the autotrophs convince him to put on a vest, and they all want to go out for a walk, and they want to start talking to the other autotrophs. They pick up pieces of autotrophs in different parts during their walk. They get ones that smell great. They get ones that make them feel great. They find ones that sense danger. In this picture, we find ones that can actually hold water for the whole community. The autotrophs convince us to create an entire suit where they really want to travel around and visit their buddies, and they convince us that by wearing them, we will be able to become our best person. We start to develop patterns. We develop a whole ensemble or couture of pieces that you can combine, wear, depending on whether you're in or out or how you want to feel or whether you need a massage. We start putting those together. We start seeing what the fronts of those will look like. And here we are. We started with Amazon, and now the autotroph couture is complete. It's deployed. People around the world are starting to wear it. And the autotrophs convince Mogi that the next thing they need to do is some housing for all of their buddies. And they introduce us to this type of orchid called a Drachia. And they also introduce us to this physalis fruit as a structural idea. Similar to the prosthesis, we create a basic structure and we can create components that can be inhabited by different typologies of plants. And we start test fitting those. We develop the full type prototype of those. And then we start populating the corpuscle. In this case, we're going to call it an arc from here on out, with a variety of plants that have the ability to sustain an entire family of 6 forever. Inside, we have areas for food prep, we have garden living, we have plant-based furniture, we have studio, we have rest areas. We get a first view of what it might be like if everything grows as planned. And then the arcs start to be deployed to remote areas of the Earth to continue to communicate. So the autotrophs can now communicate with humans. They have this group that they're with. They've created outfits so they can wander around. Now they've created this home that they can deploy in different parts that are exotic and meet more autotrophs. And we also, for the first time, start looking at areas of the world like the Great South Pacific Gyre, where plants are growing, but maybe not in the way that was originally thought of. The ARC gets invited by the Egyptian Ministry of Agriculture to create a campus. You can see here are the Great Pyramids, so it's a kind of a fairly empty site south of the pyramids to create Osiris's Acacia Botanical Academy. Osiris is an ancient god of nature and plants. Acacia tree is a historical tree that supposedly when Osiris was killed, his body and coffin appeared back on branches of an acacia tree. And we start out making plans of what's going to happen in this academy. And we look at creating a great step well for fabrication of the arcs. We have clusters for education. And we start to think about the types of public and private spaces to be considered, and maybe what they would be like if we used, again, the autotrophs recommendations. So things like beehives and nests and the ways that epiphytes attach to trees. We start looking at computational design strategies to develop what we're going to call kind of the 8 chapters of the academy. And we start to create clusters and aggregations and populations for the branches. We are really trying to keep life simple, and we have one basic branch that we're aggregating. And we start doing test aggregations of what those branches might look like. And we select one, the step wells begin to be constructed, the arcs start fabricating, the great tree begins to get put up. As the arcs are fabricated, they're lifted up into positions in the trees and their chapters in the academy. And maybe this could be what a view looks like with the arcs growing inside the fabric of the tree, very preliminary. Then we start trying to imagine, how do we get around to all of these places? So probably the tree's big. Maybe we can create a divine network that hangs from the branches and attaches to the branches and has the ability to circulate up and around to the neighborhood districts via horizontal public paths. We start allowing Houdini to create an aggregative system to allow us to understand the shortest paths through the tree, more of that path idea. We start to develop what the vines could be like with the idea of xylem and phloem and this almost water-like molecules that people could inhabit flowing through those. real early depiction of what those molecules could look like. Then the the autotrophs are back into gear, and they introduce us to the idea of this sundew and its ability to curve and articulate itself and to actually hold insects and to articulate fully or partially. And we developed the first pollen-powered vehicle for
Walter?
the personal.
Yes, a few more minutes. Just
I'm good.
Yes,
I'm good.
yeah.
Thanks. The pollen based on ion propulsion, the sundews park and grow. They park outside of the rose portals to the arcs and to the divine network. Some images of what that starts to look like as it's developed in details. And then we go back and, the Academy is doing tremendously well, 3 more minutes. And the notion is to deploy the academies to Point Nemo in the Southern Hemisphere gyre, where all of this unwanted human material ends up. And we start looking at generative studies of how to circulate and move around into this new structure that we're gonna, from now on, it's gonna be the thing's big, it's gonna be the 8th continent, it's a quarter of the size of Australia. It starts to have circulation networks, ports, academies. We go into the details of how circulation moves around, and even in this fine grain, some of the arcs being further out into nature than just up in the tree. We get our first view of maybe what that's like. And, what's next is really a lot of knowledge being dumped in from nature. And I wanted to show the Big Yellow Taxi record that's going to be the basis of the quick movie that I have to show you.
Paradise, put up a parking lot. It's a clean hotel, a boutique, and a swinging hot spot. Don't it always seem to go that you don't know what you've got till it's gone? It gave paradise, put up a parking lot. They took all the trees, put them in a tree museum. And they charged the people $1.50 just to see them. Don't it always seem to go that you don't know what you've got till it's gone? They paved paradise, put up a parking lot. Hey, farmer, farmer, put away the DDT now. Give me spots on my apples, or leave me the birds and the bees. Please don't it always seem to go that you don't know what you've got till it's gone. They paved paradise, put up a parking lot. Late last night, I heard the screen door slam, and a big yellow taxi took away my old man. Don't it always seem to go that you don't know what you've got till it's gone? They paved paradise, put up a parking lot. I said, don't it always seem to go that you don't know what you've got till it's gone? They paved paradise, put up a parking lot. They paved paradise, put up a parking lot. They paved paradise, put up a parking lot.
Thank you.
Walter, it was super energetic video. You make this whole dance. Like actually, everyone was asking who was starting to dance on the vibes. Great job. After meditation, you picked us up. Thank you so much.
Yeah, thanks for letting me rock out. Go to Nashville. Yay.
You did such an incredible job throughout the whole program. You actually used a lot of challenging computational strategies to get to some of the ideas. You were very true to your project from the beginning until the end. We see how you're merged with your world, even your t-shirt is rocking it today. So thank you so much, Walter. It's really been a pleasure.
Thank you. It's been a pleasure being here. I can't believe.
Thank you very much.
It's
an amazing project. Yeah, very interesting. Thank you. And congratulations also from me.
Hey, Walter, good to see you. I want to say a few words. Hi. I really appreciate how submerged you are during the whole time. I can see in your concept, and I know you had to overcome a lot of technical difficulties, but I can see you finally got to a result, and I hope you're happy with it. I think we all can say we are very happy to have you in this program. I was wanting to ask you what's next for you. What are you going to do with all that skills now that you have? Do you have any plans now?
Back to bathroom renovations or something. Who knows? Yeah, a lot more skills are, still, I'm not going to be okay for months after going through this. This has been a lot of form finding. I've been an architect for 40 years, and form finding has never had this many cool tools. And, the hope of the metaverse, eliminates gravity and heating and air conditioning and plumbing. So I like all of these places that it can lead to. I'm kind of a farmer at heart. I love building. I like getting my hands dirty. And
good.
Yeah, I really want to experiment a bunch more. So you were all great with helping me to have this ability to experiment in a different way. It's been kind of a source of inspiration my whole life. Having to do a master's made me think about how early I was introduced to plants, and how much of my life I've spent with them, and how many great buildings I've done with green roofs and gardens and public spaces. So can't wait to break out the new tools.
Yeah, I wish to you a lot of creative adventures in the future, and just stay as creative as you are right now.
Thanks.
Yeah.
Yeah, congratulations, Walter. Great presentation. And yeah, I think right from the beginning, seeing your work in the beginning, and I was very interested in seeing how that evolves into later chapters. And I really admire your presentation. I think it has come off really well. Congratulations.
Thank you. And you again have inspired me more than you can imagine, especially with materials and textures and kind of what's really possible. Form factors is such a small part.
I think there is no stopping you now. I think there are going to be some wild projects in your future.
Yes, and thank you for thinking about nature always. Plants first.
And also being so dedicated, right? To it. That's a big portion of it. Taking it so seriously, diving in, really pushing your boundaries. And exactly, you have such vast experience in architecture, 40 years before you, and being so open into jumping into all these new worlds and techniques, and have so many different people giving you like sharing with you like their knowledge, like, so it's a big thing, you know, like being open after like being so many years in the industry.
You know, Pavlina, it took me a tiny bit to understand how valuable the tutors were in the class. So you watch all of these videos and you think you learn stuff, and then you just get stuck, and you're stuck. And no matter which way, horizontally, vertically you go, you don't get unstuck. And then, you know, you reach out to Kior or Radul, and wow, next thing you know, they have like 5 other ways that you could answer it, but they can get you out of the problem that you're stuck in. And early on in the thesis, I wasn't so good at asking the questions. You know, I kind of felt embarrassed about it, you know, that it was just like a design review. And I was just really having problems with the programs. And it was, wow, what masters to be able to be helped by.
Thank you for your kind words, and I'm happy that like it was a very positive journey for you, and I'm sure that we'll all keep in touch even after the master's program. We're all in one community, and we're going to have more opportunities to be together, to learn from each other, and keep growing together.
Thank you, Walter, for the amazing experience. I think you've grown a lot, even for like the 9 months. Thank you for like bothering me and asking questions. And yeah, it was a very interesting, nice experience. Thank you. And then we can move on to the next team. It's again P9, but we have Naresh.
Hey, hello. Let me share my screen. Yeah, I think you can see the screen.
Yes, so just a note, Naresh and Walter share a similar theoretical framework, but the design decisions are different. Design outcome.
Okay.
Yes.
Okay, thank you. So welcome to my project on the cybernetic autotroph evolution. This is Naresh. Here I'm investigating the cybernetic autotroph to achieve the ecosystem equilibrium in the world. I would like to thank Walter for his inspirations in the theory and framing some parts of the theoretical framework. To share with the journey, so this is the journey from the prosthesis, the corpuscle, the amalgamation, the kinesis, and the cosmogony. To take you to the theoretical framework, so we live in a period of constant change, uncertainty, and crisis, where the economic and the social changes impact our day-to-day life. Climate change, ecological issues such as global warming, air and water pollution has created a critical need to turn back and look at the massive destruction on our mother nature and ultimately creating a planetary imbalance. To overcome this, we want to unlock the nature solution and seek the knowledge of the autotroph, which is a collection of plants, algae, and bacteria to tackle the planetary issues. So over the past decades, plant science has revealed that certain plants are much more than just carbon-fixing entities. They possess a plant-specific intelligence with which they can manipulate both the abiotic and the biotic environment, including the climatic patterns and the whole ecosystem. We aim to get the inspiration from the autotrophic process and use the cybernetic autotroph as a tool to communicate, co-create, and co-develop with the family of the autotroph. The symbiotic relationship between the autotroph, humans, and the machines offers us a way to redesign and rewild the city to reach a state of equilibrium. Let's deep dive into how this vision is realized. So it starts with the cybernetic autotrophic interface from the chapter of the prosthesis. Here, we aim to design a cybernetic interface that integrates physically and digitally with the human body, preferably as a wearable probe, to communicate and interact with the family of autotroph. So our first steps will be deep diving into existing knowledge and the resources to design and fabricate prosthetic wearables. The wearable's primary function is to acquire sensory data about the autotroph trigger timely feedback, deliver sensory responses to the humans, as well as it can harvest power and connect with the corpuscle unit for the data processing and the transfer. So these are some of the design explorations where I explored some haptic feedbacks, some kind of like light guides, some autotrophic growth that can happen all along the body, as well as the cybernetic interface. So this is the overall design of the interface or the probe, where you can see in the closer look, it has a lotus inspired bio-inspired structure. The algae can flow to create more energy, some kind of like spectral sensors, as well as silver electrode in order to communicate and gather the data from the plants. Some haptic vibrators, pressure actuators, as well as some thermal pads for the haptic responses to the humans. So these variables can also host one or more families of the autotroph using the plant growth mesh that you see here, and use the sunlight and the air to create energy using the algae bioreactor that is on board. Humans will use this proposed cybernetic glove as a digital interface to connect and interact with the autotroph available around the environment while visiting a garden, natural reserves, or forests, or even hiking and walking around the locality. So with this, I'm introducing you to the corpuscle, which is in the form of the autotroph arc of a scalable, integrated housing and the scientific center to connect and learn with the various families of the autotroph, as well as compute logical patterns, fabricate autotroph-derived products informed by the knowledge of the autotroph. The corpuscle design for the cybernetic humans is primarily analyzed and proposed considering the crucial elements of the autotrophic needs, such as air, water, sunlight, and the nutrient-rich soil. On the other hand, human factors such as nutritional food, protection, living conditions, and the safety needs also considered as an essential role in designing the system to achieve a symbiotic design co-hosting both the humans and the non-human agencies. So this is the overall look of the autotroph arc in the form of the corpuscle. This integrated arc forms a cohabitation space, preferably adaptable to any deployed site with access to water, soil nutrients, as well as the air. Here you can see some of the indoor garden, energy towers, as well as a connection to the nearby city. Here's a closer look of the interior garden, where the edible plants as well as nutritious plants that can be grown for our own research, as well as the cybernetic human consumption. This is the close look of the integrated energy harvesting system in sense of the, it can extract pure oxygen. The solar towers can able to capture a very good solar energy, convert into electricity for the entire powering of the autotroph arc. This is the water tower that can help to harvest rainwater in a more optimized way. As the humans collect the data about the various autotroph with the help of the probe, the plant AI data tower that you see here will help to analyze, model the autotroph data, and convert them into feasible solutions. Humans then will use these solutions and carry out experiments in the research center that you see here, having the multi-material printer to fabricate structures and test them in the real-world situations, as well as they can able to redesign the construction of the entire arc. With continuous understanding and the interaction of the autotrophic family, the autotroph arc can emerge as a modular as well as optimized structures using the biological materials informed by the autotrophic knowledge. So with this arc, there comes the autotrophic arc society with the combination of multiple arcs together. We aim to create a self-sustained, intelligent autotrophic society that emerges as an aggregation and adaptation of various autotroph arc knowledge, adaptable to any deployed site by analyzing the social, environmental, personal, and the communal needs of the cybernetic inhabitants. So I took the Marina Bay area of Singapore as one of the aggregation site in order to test and verify the interaction of the aggregations. So these are some of the explorations where the corpuscle units, which is the arc, can able to be aggregated in the nature-inspired location, as well as which can able to be aggregated within the city blocks. With this initial investigator, this is the overall look of the amalgamation site, where we can see 3 different clusters that is aggregated based on the site's condition, such as in the cluster A, it can able to spread more evenly. The cluster B, which can able to grow in a more vertical direction, which more housing units rather than the garden integrated units. And the housing cluster C, which can able to accommodate more living space together. So as every autotroph arc will have its unique set of families hosted in them, their gathered knowledge is combined with the neighbors to form an intelligent collective organization. So this sharing and the flow of the autotrophic knowledge based on the experiments, experiences, and the learnings can occur through social networking and relationship building with the neighbors. So in order to achieve this, a suitable architecture, such as a community park, can be integrated across the org to cultivate the sharing of mutual knowledge, collective interest in the needs, and sharing resources. So with this, let's continue to the Autotroph Arc network, where the network connects the indigenous ARC communities to explore new possibilities for the shared resource, co-development, and mutual advancement with the help of the private and the public transportation network, more genuinely inspired by the green algae. Yeah, so this is a kind of like a network that is explored by the Houdini networks. So here we aim to build an optimized mobility system in the transport network that connects across various autotrophic society envisioned in the previous chapters. So these are connections between 3 different clusters, which can form the public network. This is some of the network exploration for one of the housing cluster, where it can connect various node points of the single cluster, which we call the private network. So this is the closer look. The transportation network for the public is actually designed by considering the algae's biofuel generation, as well as the air purification capabilities. Here you can see the public stop, the public vehicle that is going to connect different clusters by using the algae channels. This is a closer look on the private network, where the private vehicle is going to go in and around the single cluster such that it can able to investigate the plants, as well as the autotroph as the rider is actually going around the network. For a closer look, this is the private vehicle. This is the public vehicle, which is Navigator. It can host around 20 to 30 people to move from between housing cluster A to cluster B and cluster C between various sites. It consists of a pollutant-free exhaust system informed by the algae-based biofuel processing unit and biophotovoltaics embedded glass enclosure, as well as algae-powered headlights. This is a closer look of the public station, where the people can commute in the public vehicle. On the other hand, this is the private vehicle, which is a ranger. He can able to transport medicine as well as water in the private network in order to deliver the water and the medicine to the required plants as and whenever necessary. This is a closer look of the private parking, where the private vehicle can able to recharge their medicine as well as the water whenever they are necessary while traveling along the private networks. In the cosmogony level, which is the cybernetic autotrophic evolution, the vision of this chapter is to design the solutions to construct an equilibrium-driven cosmogony that emerges as a collective adaptation and implementation of the various autotrophic knowledge in the day-to-day life of the cybernetic humans. So this envisioned cosmogony is actually developed based on the inspiration from the algae, as well as collaboration with the autotroph. So this cybernetic autotrophic system is deployed on the country scale, which is the country of the Singapore is chosen for the deployment and to tests. So the master plan is composed based on the first logic is hydrotropism, where it's a study of the plants towards the water resource. With this, I try to track down the water network and try to make the algae to come and occupy the entire city to form a network. And in the second level, I try to do the urban rewilding by mapping out various national parks, as well as the parks, as well as vegetation location around the site, and I connected them to form the tech centers as well as energy clusters, forming the top-level transit network. In the third stage, I tried to map the existing highway network system so that it can be used as a private network to connect various small clusters in and around various sites of the city. With this, I came up with the entire cosmogony map. This is in a full scale. To deep dive, so this is one of the close-up look of the tech center, which is connected to various ARC clusters. All those green things that you see are the small corpuscle units or the aggregation clusters. This is another look of the site, where we can see a permaculture research space where the humans can able to grow different varieties of the autotroph, and they can able to investigate how the growth occurs, how the growth can be modified, how it can be used in the human processes. In the next level, where you can see a community park is actually defined by connecting various different clusters that has been mapped around the site. So this is the overall look. This envisioned cosmogony develops as a succession that occurs to the autotroph arc society in a timely fashion concerning the regional conditions as well as the changes. Although the change can be dynamic, the network of the society that emerges algorithmically will eventually aim to achieve an equilibrium state. With self-regulation and constant feedback of the deployed cybernetic system, the planetary boundaries are in control to achieve an ecosystem equilibrium. Coexistence, mutualism behavior, as well as ecosystem equilibrium will be driven for the humans as they become a part of the autotrophic world by constantly trying to understand and appreciate its natural abilities and reach a state of equilibrium. Yeah. With this, let's have a look at the world that has been created. Thank you.
Thanks, Naresh. Very good job.
Thank you so much, Naresh. Congratulations for the amazing work.
It's a lot to dive in, like from again, like one person team. So really congrats for the hard work. It came amazingly. It's again, like I'm happy to see that it's reflecting again like who you are and your background like in robotics, because like we see even from the first chapter, right, like how you're looking into the details and a specific part of the body and how to work with that and really design like towards that side. And I'm very happy to see, because it's like an incredible amount of work again, like for just one person, like to put this together. And I think that also a lot of the chapters where you're working with amalgamation with larger bodies, you are actually like very successful in a way that you are representing the work in a very smart way. Like many offices in the architectural world, like a big architecture and like from OMA, like they have like this like more like playful diagrams, right? Like, so you were smart like to visualize it in this way so we can see the different units, the, you know, the experience that like your city provides. Yes, exactly, like those diagrams and, you know, like the three-dimensional. So really, really well done. And I know like how difficult it is like to be like again like full-time employed and you know, like go through all these challenges and learn. And I actually want to hear from you, like you know, also like about your new endeavor and how computational and design like has it been like enriching like some of your like other aspects of your work? Like do you have any new ideas of what's next for you?
Yeah, so thank you for the comments. And thank you especially to you to pushing me to come to the final stage here. And yeah, so it's been a lot of a lot of knowledge that we gained during the course, a lot of softwares and the workflows. The time was quite difficult for me to explore a lot on the software, but yeah, I got a hint of like what these softwares can be achieved, what the workflows can able to bring the ideas more into reality. So it's about the next step is to how to apply these kind of like techniques, and in terms of like in my own field in robotics maybe, and try to see what new things that can be created or visualized and make it into a real project. Yeah, so maybe I'll be working on the cybernetic interface, the probe. It might be a real product soon. Yeah.
That's
Yeah,
exciting, exactly, like the other aspect of things, right? Like, but I'm glad to see that also like you had the opportunity like to dive into design in general, right? Like computational design, especially because like your mind is, you know, like so well, you know, like prepared for this kind of, you know, like endeavor. But the design part also, you know, like about like just beauty, design, proportion, you know, like things that like we've started like talking about from the beginning. I definitely like see like how you really like are, you know, stepping in into that direction like in a very great manner. So thank you really for pushing and for being here today and for really killing it, Naresh.
Thank you so much.
Yeah, congratulations, Naresh. That was really great, and I too commend you on like the enormous amount of work and effort that you put forth, and I liked many parts of the project. I thought the urban scale was not quite as successful and as kind of like the interior scale and the product scale. So I really encourage you to push that. We had a discussion yesterday. I forget who the project was by, the people who designed it, but it was regarding this idea of just kind of distributing the same module over and over again. Just like a collection of stuff as opposed to kind of a designed urban experience. So that I think is probably the weaker part of the project, but definitely can be pushed forward. And then the other thing just has to do with like the rendering and what I was saying. Like, first of all, I really encourage you to substitute the font. That's one of the fonts that like graphic designers really think of as like kind of amateurish in a way. And it kind of puts up a flag about the project when you use fonts like that. And also the deployment of vegetation in your scenes, you know, you could do something like scan some vegetation or do something to make it look a little bit less kind of like cookie cutter repetition. And I know it's very difficult to do and probably like the last thing you wanted to think about, but it's, you know, you could easily push the project into a new level if you just do these minor tweaks and do a little bit of redistribution of like the urban design so that there's a little more variation in scale and perhaps like formal moves. But otherwise, it's a great project and awesome.
Yeah, definitely. Yeah, thank you. Yeah, the vegetation is actually the important aspect that has to be considered. But
exactly. Yeah, I thought of that
we have to
too.
do a lot of work in order to make it more to look very beautiful in such a way. Yeah.
Well, the way like games like Fortnite and other UE5 platforms cheated is they really just scan scenarios in 3D and just bring them in. And there are lots of online kind of cloud-based ways to do that so that it's not super expensive.
Okay, I'll check it out. Thank you.
Thanks, Naresh. Thanks for everything. I really, like, yeah, we really push it. Like, as you can see, it's 2:20 a.m. on your time, and thank you for the dedication, and thanks for finishing the project.
Yeah, thank you so much, too.
Thank you. Okay, we have next team P6. We have Brian and Elena. Hi. Hello.
Okay.
Okay, hi, I'm Brian and my partner is Elena. You can see my screen, correct?
Yeah.
Yes. Our project envisions cyborgs employing synthetic analogs of natural precedents, such as mycorrhizal networks, mycetozoa, and coral as functional exemplars of mutualism, through which a more interdependent society might realize a more mindful and compassionate existence. In Intercessor, we develop a bionic, sensorial, and mnemonic prosthetic interface with the purpose of engendering empathic interconnectedness. Cochlea, our corpuscle, explores how this interconnectivity establishes dwellings of functional synthesis through the concerted attributes of multiple cyborgs. Remerge elaborates on this process to conceive neighborhoods of symbiotic relationships as functionally different corpuscles amalgamate according to complementary logics. Meander realizes a local interdependent transport system that connects the various neighborhoods through unconventional means. And Interweave, our cosmogony, integrates all these aspects into a cohesive and synergistic whole. Welcome to Ouroboros. Our project Ouroboros envisions a society rebuilding from collapse. Sorry. A collapse caused in no small part due to the bionic and neuronic implants in which inescapable consumerist stimulation, exalting misinformation and the spectacle more than knowledge or truth, left people stranded in virtual worlds of isolation, enthralled to the spectacle. But in the wake of the social upheaval, these same technologies, the implants, are appropriated as a remedy. Flows of stimuli are inverted, and people instead use them to engage with one another, to share themselves in a compassionate and communal manner, and to fashion a new world of ideals and systems founded on this ethos. The prosthesis intercessor is the germ from which all subsequent manifestations of the Ouroboros derive their functional and aesthetic qualities. We say germ not only figuratively, but literally as well, in that synthetic fungal and mycetozoic analogs that manifest in the prosthesis establish the fundament on which the overarching system depends, at every scale, from the microcosm of the brain to the cosmogonic network, revealing emergent properties at every turn. The intercessor comprises bionic neurons enshrouded in a slime mold-inspired matrix that emulates the neuronal network. It penetrates the brain as well as most of the primary organs related to perception and memory, sight, smell, hearing, and touch, and interfaces with human consciousness. As notions of self are generated through the processes of memory and perception, the cybernetic AI aspect intervenes in incoming information as well as the recall of memories, much in the way the brain already does, allowing the individual to gradually engage with the information in a meaningful and productive way. These extremities, splines, not only connect the sensory modules from one to the next, but can intersect with one another to form nodes where memories and sensations can be processed and stored, but they can also be confabulated to generate novel experiences of reality. The prosthesis incorporates various other bionic components, some of which are capable of changing color or emitting light to communicate emotional states broadly, while others can dissolve material or generate energy, giving the cyborgs utilitarian attributes. The prosthesis is extensible, by which the splines can reach out to engage their environment, but with a more meaningful purpose of interconnection with other cyborgs to share thought and emotion, establishing empathy and solidarity.
As cyborgs come together for mutualistic purposes, the qualities of the prosthetic splines allow them to extract and transmute materials from the environment to create habitable structures out of wastelands of ruined cities. By combining their individual capacities, like dissolving and illuminating, they collectively create a functionalistic system. Through time, the inhabitants connect and reform their relationship. The shell interconnects and evolves, creating levels of privacy and variety of spaces. The structural elements support the shell as a synergy of materials flow through the splines to the processors. The aesthetics of the cochlea derives as an amalgam of the personalities, emotional states of the cyborgs within. The corpuscle is a home of comfort, a shell of empathy, sharing, and self-expression. On the inside, the space adapts according to the current emotions and desire of the intercessor through shapes and patterns. The kinetic furniture adds to the 4D quality by sensing and supporting the movement of the cyborg. The inside affects the outside world, and the novel continues. The corpuscle is similar in logic to the prosthesis in its ability to recombine discrete qualities in novel complementary ways. In our amalgamation remerge, as corpuscles proliferate, they aggregate into largest assemblies of communities where their specific capabilities amalgamate into functional systems which reconstitute infrastructure that was lost in the fall. Taking advantage of the tallest structures that remain, where material is plentiful, the corpuscles effectively parasite the buildings and transmute them into novel architectural typologies, expressing Ouroboros mutualistic principles. After multiple iterations, complex patterns of relationships emerge to establish neighborhoods of diversified elements within a larger urban context. The units follow a logic of recyclability, as the old ones can be consumed or regenerated. Fungal fruiting bodies displace the original structures where programmatic spaces and transit systems interweave. The ground creates more opportunities for social instances. There are 3 units typologies that together form clusters that differ in density, which affects the relationship of the inhabitants. Materials are transferring and being processed through the splines. Temporary structural elements uphold buildings as they are consumed. And each tower is communicating with visual signals on top.
In Kinesis, we envision public and private vehicles that swim and float through the cyborg city, invoking Guy Debord's concept of the dérive, to be deliriously lost, or at the very least, emotionally disoriented, in a way that compels the traveler to have unanticipated experiences. This concept contrasts with the present understanding of time and movement. It encourages travel with no preconceived destination. Here, the public conveyance, the cloud, perambulates along its ambiguous paths. And in this image, we see the private network convoluting within and without the amalgamation superstructure.
The private vehicle is a jellyfish-like manifestation that swims through a liquid-filled network of splines that interweave throughout the amalgamation superstructure. The fish can enter the large public convenience to transfer between towers. The system consists of 3 types of splines: the direct movement, the playful cubes, and the orbital machinery. That makes the journey fascinating and unpredictable. The exterior of the vehicle is imbued with the same biosynthetic material, so the patterns and colors depend on the passenger's emotional state. The vehicle movement is controlled mostly by its tail, helping to process the liquid as well. The glowing splines send signals to the passing vehicles using bioluminescence. Just like the corpuscle, the cyborg is integrated with the vehicle through splines, which afford them to comfortably support their position, as the intercessor can convey their wishes concerning destination and velocity. The tubes create spaces for the vehicles to park and recharge. The furniture splines lead the passenger out to continue its journey. The public clouds slowly meander through the city along fluctuating paths and are less a means to a destination than the destination itself, in essence, a floating park. Arrayed armatures all along these towers provide moments for the public vehicles to dock and from which they derive power. The public component comprises a few conjoined yet separable units which transpose around the centroid mass in an orbital motion. While docking at the stations, the overall mass continues, allowing the passengers and private vehicles to embark, disembark. The park inside meanders as well, so as to allow unexpected social meetings to happen.
The level of cosmogony, interweave, is both the end and the beginning. It is the culmination of our presentation, but the inception of our story. It manifests at the greatest scale the essential nature of the microcosmic beginnings from which it derives, and becomes the source on which all previous manifestation of the Ouroboros depend. But to begin, in this phase, we explore the unfolding of the cyborg society from its rebirth following its societal collapse. In order to rebuild and reintegrate a dilapidated and fractured world, cyborg society repurposes its biosynthetic technologies towards the development of resource-finding appendages, which evolve into infrastructural networks over time, that ultimately resolve into cosmogonic transit networks connecting the burgeoning yet isolated communities into a unified whole. Derived from the logics of slime molds, these protuberances are realized as a series of overlapping and intersecting reticulations manifesting temporal increments of redevelopment. As society first contracts, neighborhoods with the lowest median income are the first to crumble. Refugees gravitate towards large parks and the buildings that surround them where wealth has slowed encroaching entropy. As resources dwindle, cyborganity begins to expand its search radius of resource reclamation. Their search paths begin to intersect and merge, establishing stable networks of long-term use between the most heavily populated areas, which in turn become major networks. Simultaneously, as materials are sought out, their availability and the ability to find and exploit them is differentiated according to the initial wealth distribution at the onset of the scenario. This creates secondary and tertiary search parameters that inform the aesthetic of ensuing transit networks according to these search logics, which are reflected in their emergent qualities. Yeah, that's great. Okay. Sorry. These qualities in turn inform the distribution, density, and programmatic aspects of the amalgamations that emerge around the networks. First to be exploited are the vast rubble wastelands that were those porous neighborhoods. Ruination and prior despolation create dense rambling networks attesting to a random search methodology. The transit system established on these prospecting paths is thus slow due to the convoluted nature and limited carrying capacity of these narrow articulations, thus engendering predominantly suburban, sparse residential neighborhoods. Between the ruins and stable cores are interstitial zones. Because initially salvaged material is transported through these zones back to the cores, the paths are elongated and more direct and become the fastest means of transit. Semi-dense amalgamations develop at the nodes of intersection where, like fungal rhizomes, the convergence of materials give rise to nexuses of synergistic opportunity. Between the ruins and, the major networks established from the confluence of incipient search paths primarily connect the cores to one another, and because they are born from and connect the areas of highest population density, they tend to be the broadest of routes conveying the heaviest amount of traffic. Because it is here where the first amalgamations form, they appropriate the verticality of the buildings they parasitize and tend to be the densest. Here, interstitial circuits manifest as the synthesis of attributes of converging networks, delineating yet interweaving the perimeters of the adjacent regions. The resulting distribution and disposition of these high-density, slow-moving conduits establish areas for public spaces and venues to develop. Over time, these various networks shift and wander as they seek new materials, transmigrating the cities and neighborhoods along with them, growing and contracting in accordance with resource availability, leaving behind topological meanders that nature may ultimately reclaim. And so we arrive at the conclusion. In overlaying all the chapters, it may be understood that the relationship between the implants and the cyborg to the relationship between the cyborg and an overarching cosmogony are scalar and recursive. It is a synergistic process that reifies Ouroboros's underlying concept of reciprocity, where nature and cyborganity simultaneously interpenetrate and separate, an interwoven dichotomy of past, present, and future, of form and void, and of the technologic and the human. Thank you.
Thank you.
Thank you so much, Brian and Elena. Amazing project, a really unique one. You have so powerful design language that you are following from the beginning to now. And you have an amazing teamwork during this whole time. So congratulations and thank you so much.
Thank you.
Indeed, guys, I think it was an interesting journey of learning, of like getting to this point, but I think that now everything is coming together, right? Like in the last presentations, more and more so, like the whole language, like the colors, the palette, the video, like everything, and just immersing us in this very poetic world of yours, which I really think that this is the most poetic project of the master's program. It's beautifully put. It has like a quality that, you know, like we don't really see often, right? Like it's a very, very unique language. So congratulations for that, and congratulations for, you know, like pushing so hard and growing, and, you know, like really pushing your skills like out of, you know, like where you started. And that's the most important part, right? Like learning and bettering ourselves like throughout this process. It's not about like, you know, like even if you made like a bigger step, you know, like if you came with less knowledge and you made a bigger step, it's a bigger achievement than, you know, making a smaller step if you already had the knowledge like beforehand. So it's great what you did, and it's kudos to both of you.
Thank you.
Thank you. Thanks for pushing us as well, Kat.
A really, really beautiful project, and I agree, extremely poetic and inspiring. I guess really the only thing I thought when you started the film, starting on very long shots of extreme close-ups, I didn't think was super successful. Sort of like you have to find that sweet spot of, you know, how tightly are you going to zoom in before somebody just kind of loses all reference and is sort of not interested. So it took, you know, maybe 15 seconds to actually get to a view where you go, oh, that's what it is. So maybe just re-editing the beginning because you got to a point towards the end where it was like, wow, this is amazing. So just kind of refilm, you know, re-edit that little portion, but otherwise it's amazing.
Yeah, I'll agree with that. We can work on it.
Yeah, hi guys. Very beautiful project. I totally admire almost all the work of all the chapters. Like I really like how detailed you have modeled everything in your processes, and like it looks really great. Only one comment from my side would be that the way you have these objects and these elements that in the processes where you have a very specific spot, I feel that maybe in your amalgamation chapter, if you, instead of going everywhere, if you had only few spots where these elements are injected, that would have kept the consistency. But other than that, I love the overall visual language, the colors and everything is really brilliant. Congratulations.
Thank you.
Oh, I did have one other thing I wanted to point out, and this kind of goes across the board to many teams. You guys did so much research, and you researched scientific language, you researched theoretical ideas. I mean, a very high density of material. And I kind of make the same mistake in my presentations. I'm a fast talker. And because I know my project really well, I just super densify everything that I say. And I don't remember, although I am forcing myself to do that more and more, I don't remember that the person listening has no idea what I'm about to present. And so my suggestion is to listen to somebody like Krista Kim, the person that designed the Mars house that was sold as the very first architectural NFT. And she has a very it's almost like a meditative way of speaking. She really chooses what she says very carefully. And it's always like kind of targeted to like express the maximum idea with a minimum amount of words. And it's much easier to digest. So I was having trouble because you were interjecting all kinds of scientific concepts and they were mixed in with like sophisticated methods that you guys use to kind of amalgamate these ideas into design. And at a certain point, I just kind of like stopped listening, just because the beauty of the images was overriding my capacity to absorb what you were presenting. And that was true of a lot of teams. But it especially stood out to me in this last team, because I kept wanting to like, okay, let me absorb this slower so that I can really focus on the images at the same time.
Yeah, it's a challenge to put all this work in 15 minutes and really communicate with you.
But I mean, I think the temptation is to think that you have to present your whole process, everything you ever thought about your project, everything you found, which is really cool. But in fact, for us to just absorb the story of your project and to be able to also focus on the design elements that we're seeing at the same time that we're hearing things, I mean, that itself is an art. And I think we get better and better at that as we progress in our careers and as we present more and more to clients specifically, because there's nothing like presenting to a client and having like a really puzzled look on their face at the end, where they just they weren't able to absorb, you know, a very dense presentation. So keep that in mind, because I think whatever audience you're actually presenting to, it really matters how you actually say the story.
Yeah, definitely. We're trying and rehearsing a lot exactly those topics. Really important to be able to explain your project in this short time frame so that everyone can understand, even people who are completely outside of the field. But it's not always that easy. Maybe it takes some more time sometimes to practice.
And the project is, it's not as, I mean, that's all the project, but this one is especially, it's a little bit difficult to explain, like in just 15 minutes. So yeah, but I think you guys did an amazing job on doing that. And like the feedback was great. So you can like still work on it and present it in maybe a different way. But for now, thanks for the jobs, thanks for the experience. And I can see a lot of growth in both of you. So yeah.
Amazing project.
Yeah, not a bad comment to say, like that, you know, like what you were saying was like, we were like totally overpowered, but like amazing imagery, right? So
I'll work on it.
thank you, guys.
Thank you.
Thank you.
Okay, so we move on to the last team for the presentation. Last but not least, B7. Eva and Arantxa.
Hello.
Hello.
Hi guys, can you hear me?
Yes, hello.
Okay. Okay. Well, welcome. In a future where resources are lacking and climate change has reached critical points, a new era is here to bring hope to the future generations. My partner, Eva Hafeez, and I, Arantxa Nava, we will present in our topic, More Than Memories. This is a brief view of our work during the program. Proposal area, this is the amalgamation part, and we finish with this. But now we're ready to begin. As a human race, we react to the problem by generating a solution using technology, all this to survive. There are two main concepts that will shape this world. The first one is molten salt nuclear energy that we will call element 19, and it will serve as a power source. The small number of resources needed to generate a big amount of energy will allow us to power a complex city. The second concept is the use of memory as data to provide insight knowledge stream from our brain senses. Multisensorial perception generated in our brain will be extracted and used to optimize the resources. Now that division has been introduced, let's start with the prosthesis. TOR-RAM is the human machine of the future. It is composed of two layers, the TOR mechanic body and the RAM garment. This new anatomy enhances the central nervous system and develops the body with extraordinary complex machine, keeping the brain as the processor of memories and connecting it to mechanical sensors in both layers. I will start explaining the TOR layer. This layer replaces the human body with a machine body only to provide a safe environment for the central nervous system. The merge of the human with the machine will allow us to consume less resources from our world. The TOR mechanical body is composed of mechanical organs. This is the nuclear reactor heart that serves as a container of energy. This is the second organ of the mechanical kidneys that will filter the energy from any particles. Last is the mechanism of the spine. This is the one of the vertebrae. The main function of them is to act as a port of connection that transfer with the RAM layer.
The second layer is named RAM, which stands for rendering all memories. The two primary elements of RAM are the brain and the spine. The external brain is composed of two layers that collect the data first from different locations of the body that are vital for memories and emotion generation. Second part is the external spinal cord that acts as a backup system for the external brain. Now let's dive through the process of the memory manipulation. The human body is layered and connected with different parts of tubes that collects the neurons responding to various stimuli of memories on different parts of the body. First part is an EEG channel headway that records this data coming from different parts of the body. The second layer is the functional part of the brain that translates this reading to a generative script by an artificial neural network. The second part of the processes is the spinal cord, which is the simulating structure of memories and is also called the processing unit of the entire system. This generates a unique, immersive, and interactive variation of what we perceive as realities.
With the new body of TOR-RAM, there will be alteration on social behaviors that will result in the influence of architectural theories and design. The corpuscle, the new house of the TOR-RAM, is named BIM, which stands for Bionic Immersive Machine. We will present the two models designed for this chapter. The first one is called BIM Water B901. This unit will be located floating in water off the coast of Tokyo. This is for temperature regulation and proximity to resources. The concept to design this unit was the heart, which will be pumping energy from the labs to the body and connected to the pipes that will transfer the energy to the city. The architectural program of this unit is focused on the laboratories to transfer the human to the new body. This unit will serve as a nuclear energy plant. This is the laboratory image of this unit, where you can see the TOR-RAM cyborgs use the space to research and collaborate to improve the memory exchange.
Just like a processes, the second corpuscle is constructed around the idea of data collection and juxtaposition. We are giving a corpuscle a way to be conscious and use that consciousness to manipulate memories, resulting in a symbiotic relationship with the cyborg. The corpuscle is mainly divided into three parts: the living, lab, and the Zen areas. The lab area is the part where the humans can remove the RAM layer to recharge and check if they need any repairs. The living area of the module has all the functionality of a normal housing unit, as well it provides the user the personal space for the interactive memories. The Zen area is the simulation area where user can either spend time with their families or alone. This area will allow the users to simulate their memories in the area along with its own memories, creating juxtaposed art in front of them. Finally, BIM is set in an immersive environment where it interacts and juxtaposes memories with its surroundings. The amalgamation project is called DNA, that is Data Network Aggregation, which aims to collect the data from neighborhood corpuses. The skyline of the city Tokyo dominates the immersive nature of the project. The urban complexity of the site incorporates hyperconnectivity and urban densification. We place our DNA tasks across the city, which acts as anchor points for the aggregation. The design consists of a kit of parts, which acts as catalog for aggregation of both residential and public amalgamations. Using a set of rules, aggregation is achieved in 3 layers. Firstly, placing the DNA tasks as anchor points. Second, achieving residential clusters around the tasks. Finally, connecting these aggregation layers with secondary clusters of public spaces. Residential tasks are a hybrid of low, mid, and high-rise buildings that connect with each other via bridges, tunnels, and walkways around, allowing public pockets for the public spaces. This is how the residential society looks like. Second aggregation is the memory plaza, which takes place around the residential tasks. Memory plaza is a shared community between 2 neighborhoods, which allow for data collection and manipulation, creating pockets for public spaces. The elements grow around the residential aggregations using the design catalogs that support an immersive experience, such as billboards, vending machines, arcades, gaming zone, which also extends as public spaces. Moving further, with this aggregation rules and ideas, we imagine a detailed digital immersive neighborhood where the collected data acts as a pigment of memories. We continue further to networks and transportations, where we continue the language of our previous developments. The design is created with a set of algorithmic densities based on the existing city data, such as buildings, roads, and urban grids. The clusters are aggregated across the city, where data collection tasks act as an anchor point. A generative simulation is achieved to connect the clusters in the private network. Stops for both public and private networks are placed keeping in mind the generated network system. After placing the public stops, we generate a system of trail networks for the public vehicles. Here's an overview of the public trails. For generating the private network system for the city, the algorithmic data are set to vector normals of attributes to each point using existing clusters as well as manually fed direction. This data becomes the hybrid with the existing city layout. Here's a catalog of some generated networks between the shared neighborhood clusters. An overview image of the networks with parking and aggregation clusters. Vehicles follow the hybrid nature of transit and are inspired by the idea of kit of parts. Spaceships are used as public transit, which is capable of carrying 20 people at a time. It is also used as a cargo transport. They can halt at different strategic points placed all over the city. MOTA is an underwater submarine that carries passengers to and from the nuclear stations. This is an interior view as seen from the underwater. Hover bike is able to fly across the city as well as surf on water. It is powered by Element 90. It is used as private vehicles in and around the city. Stops have the characteristics of docking as well as charging spots via nuclear energy, Element 90. Public stops have their own private network range to map the air traffic, while the private stops are placed around the residential amalgamations as well as around the public plazas in different levels. Along with the stops, we have a concept of mega parking, where we connect the transits from the nuclear station and city transits at the waterfront. Element 90 becomes a powerhouse source for the entire parking system. Along with the vehicle parking towers, we have placed air and water purifiers. Vertical gates for spaceships are laid out for both public and cargo parking. Finally, we lay down a network layout of the city, which is powered by nuclear energy, showing DNA towers, parking units, and vehicles around.
With the design of the cosmogony, we'll aim to find the connections of the memories between the user, the habitat, the vehicle, and the city. Molten memories cosmogony is shaped by memories. The human experience have a significant role in the city. I will present the layers that conform it. The site data, where the old city takes place and the topography of the site is presented. The neighborhood layer, where the amalgamation gets deployed. The transit layer, for generating the tiniest layer of the transit connecting residential units. The network layer, primary, secondary, and tertiary transits. And the public spaces like zen spaces and exhibits and parks. This is the city of Tokyo modified by molten memory era. This is the final map where you can see all the layers interact together. The glow in certain areas represent the memories flowing through the city, indicating higher density. Even when what we present as this map as a final image of the city, molten memory city will be in constant change. To conclude, it is important to say that Molten Memories project is designed to imagine a new present, thinking to reduce the impact on the planet and provoke evolution in the body, merging with the machine. The use of immersive memories will shape this world. The thoughts and experiences that users have will impact the collective. Now, we want to present the video. Thank you.
What an ending.
The ladies are a powerhouse.
Wow.
That was amazing. Like speechless, kind of amazing. That film at the end was just amazing. That could have easily taken somebody an entire year to get to. I mean, I don't even know what to say. It was just perfect. It does seem like the next generation cyberpunk with like in terms of the density and like kind of variety of things that are being put together, which is kind of wonderful. But everything about it was really great. Looking forward to the feature film.
Yeah, yeah, exactly.
Wait for it.
Yeah.
And really looks like the future of Tokyo, by the way. Amazing, amazing job, girls, really.
We had this obsession of cyberpunk, immersive Tokyo, and like, yeah, and like both of us are very much interested in cinematics, lights, composition, so it was like best shot for us.
Do you guys actually make films, or are you just kind of interested in it?
No, this is like our second video.
This was really your first thing.
Yeah.
Okay, that is amazing. That's crazy.
Yeah.
Okay, that's amazing. Yeah, I mean, the important thing in the metaverse is this cinematic aspect, and I think some metaverses emphasize it more than others, but it's easier to achieve it when you're just modeling something and extracting a video than it is when you're actually in a metaverse space with live actors. It's a little bit trickier, but definitely pretty amazing.
Thank you.
Yeah, that was video production that normally so many people would be working on, and you guys did it just by the CPU. That's like super badass. Wow. Congratulations.
Thank you.
Thank you. Yeah, we actually read a lot of like how to put this in like the proportion of the image, and because we wanted to like make it beautiful, like and transmit without any word, just music and the proper images. Like the storytelling, that was the most important part for us.
Your next stop is Hollywood.
Yeah, they're ready. But you know what is crazy? Actually, these two ladies were two separate teams in the beginning of the program, and they just merged this like together in the last couple of chapters.
Yeah.
Is that right? Yeah.
Yeah. So it was a big challenge because we started with different ideas that were kind of similar, like in a way, and then putting together the story, like sitting and say like, okay, what we're gonna say now was quite a challenge, especially at the middle of everything. But we did it.
Yeah, we did it finally. Like the most challenging was the environments. It was too different. Mine was a very immersive city environment, while I was underwater, and like bringing this narrative together and like using the design in the best possible manner was like a very good success for us. And like we're really happy and like proud of the works.
Yeah, and you couldn't say right now that they were two separate projects like in the beginning, right? Like that's insane.
Yeah, brilliant work, guys. Brilliant, completely mind blown by it. And the last video was just amazing. Congratulations.
Thank you.
Thank you.
Just a quick request to DesignMorphine, if you guys could repost all those links somewhere, either on social media or email them to us, so that we can repost them, because I wasn't keeping track of the chat the whole time, and then I realized you guys were posting the YouTube versions. So that would be great, and also the Instagram links to these wonderful designers so we can follow them.
Perfect. Yes, of course, and yeah, I think that this is actually our last project for the day. So I want to invite all the students to, if you guys would like to just open your cameras to see your faces.
Just a sec, I have a question. Congratulations, girls, for the amazing project. Really amazing job. But did you do it alone? Like, come on.
We have 7 cats.
Nice.
We have the cat part and the element 90 combined together.
But it's really very advanced work, so congrats.
Thank you.
Yeah, no, it was hard work, and actually this team started working on this video earlier. That's why, like, you see that, like, it was their priority, like, much earlier from when we started the VR lab. So they were really pushing for this, like, as part of their project. That's why we see the results.
I think that's important to say, right? That it takes a lot of work in order to get into this level. It's not that everyone could have done it in like 1 month or something, but congratulations on also starting early and being prepared, right?
Yeah, so learning After Effects was a thing there, very.
But to be honest, like, they didn't have like, so much of a competitive advantage, because like they literally like merged their team in like the last 2 chapters. So it wasn't that they had like more time than the other teams. It was just that they really worked together. They were really smart about like where they're going, like, you know, merging the narrative and like working smartly with like who is really like better at what portion of the work. So it was really like the best you can see, like from like teamwork perspective in such a short amount of time.
For sure. Yes. Like I would like really nominate the best part of us was teamwork. We knew the best of both of us, and like we just put it forward, like you have to do better in this. And also the benefit, the 2 projects combined, we had more assets, more like the story to explain. So we took our odds to our benefits basically.
Yeah.
Well, one interesting, so sorry, go ahead.
No, it's okay.
Okay. Yeah, one interesting thing. So I heard I was at a big event on Twitter for this metaverse that is like one of the bigger metaverses, and they were talking about their trailer and how, you know, they got all these quotes from like professional like ad agencies and stuff who charge like literally millions of dollars for trailers. And then what they decided to do is like form their own in-house like production team. And now they have like this core team. This is incredibly important. I mean, everything that you roll out in the metaverse is essentially happening, has to happen in some kind of movie format in which you're telling the story. So everything you roll out, a district or a facility or some kind of NFT drop, you have to express that somehow. And there's nothing better than that film. So I think for you guys, you already created like this very important niche for yourselves where you know how to do the design, but you also know how to express it cinematically. And I think that is going to be incredibly important, and it'll make and break metaverses, in my opinion. This element of cinematic presence and being able to create trailers that truly excite people about going into that space.
That's so true, Daniela. Yeah, very true, because like we're bombarded with so much information, visual information from everywhere, right? Like, so like the bar is high to get people excited and really involved, and, you know, like to, you know, what you want to create. And as creatives of visual content, right? Like, I think that's why for us, this lab, like the virtual reality lab, and, you know, like moving, like the students, like pushing them like towards that direction of like really, you know, carving out time and creating a video, creating a story, like, you know, like being cohesive, like throughout their design, but also representation of it. I think that was something very important for us. And yeah, Dimitri Grigorescu, he was like very big part of this, like leading the VR lab.
Yeah, and actually it's interesting to see like the Decentraland, who was the first metaverse to introduce land sales and digital assets, is just embryonic. I mean, they're really truly first generation. They are very important, especially in the blockchain NFT space. But when you look at the quality of the design and also kind of the experience, it falls very short. And I think what we're seeing now is the second and possibly even the 3rd generation. You guys might actually be the 4th generation of like really starting to execute like ideas of the metaverse in a truly artistic manner and in a kind of a theoretical manner too. And it's very exciting. I mean, this is what really the metaverse is heading to. It's not that like initial kind of pixelated, you know, cryptovoxel sandbox experience. And by the way, Sandbox, I think, is the biggest landowner in the metaverse. So we can't really dismiss anything like that, because regardless of how they look, these land sales have produced a huge economy. Like that is just, it keeps rolling on a secondary market. But this idea that a new generation of metaverses is coming, they are all going to be on Unreal Engine 5. Even Unity is kind of being pushed aside by the latest version of Unreal Engine. And I think we're going to see some really amazing stuff. And you guys are definitely in that class of like amazing metaverse kinds of projects. So really congratulations to the whole first class.
Thank you.
Thank you. Thank you, guys. Do we have any additional comments? Last comments?
Okay. Just thank you to everyone.
Yeah,
it's been great.
It has been a really great immersive experience for us.
Yeah.
Yeah, I want to actually open the conversation to you guys and give you the platform also to express your feelings, like how are you feeling after these 9 months, how is everything going for you, what is next, we're excited to hear from you too, now that all the presentation part is finalized.
Yeah, we can breathe. Yeah, I guess these past 9 months has been very hard and exciting, and then a roller coaster of emotions where we had to cry, we had fight, we had do so many things to build this, because for me it was I mean, I'm an architect and I know a lot of tools, but there was a lot of tools that I didn't, and just a beginner from scratch. That's amazing. So yeah, I'm very thankful for the people that was in the program and teaching me. And I think my classmates also were the best part, connecting with them and just talking. It was great.
Yeah, the support was really great. Everyone in our group and even the group A, we are connected, helping each other, and it's a great experience for 9 months, starting from ground zero and starting from the body and then ending up to this kind of a world. It's amazing to see everyone's projects and works.
We're very excited also to meet you in person, guys, and I think that's why this surprise was about in the morning, because I think it's going to be amazing. We were holding off to a study trip with everything what's happening in the world, but I think that will be a wonderful opportunity to come together in one space, see each other, and I'm very, very excited for that, and I'm happy that we were able actually to get the news to you today, so that's great.
I think what was so great is that it really comes down to storytelling. It's about communicating your vision, and everyone has such different backgrounds and experiences, but I think what's so motivating is that once you bring this idea to life, you want to keep it going. And so even if there's a lot of challenges, and for me, I had really zero experience with computational or 3D prior to this, but what keeps you going is wanting to make that story come to life. So I loved that part of it.
Because that's what is unique about I think this program. It's exactly that all your projects represent you, right? You were the decision maker, you were the people that were working hard into creating this narrative. There was we were supporting you through what you wanted to achieve, and that's why it's such a powerful thing to see how this is actually coming together. It's a realization of your interests, your passions, and your visions, right?
Yeah, I wanted to say that for me it was extremely interesting and inspiring to see how our both groups grew, because as you saw, we all from different backgrounds with different experiences, and to see this journey, how one gained the vision and execute this vision in a perfect level. It was so interesting to watch. Every project, literally we have 19 sci-fi ready movies I'm really happy for every classmate, teammate, and thanks DesignMorphine for making it possible, this journey, because I guess if not for me, if not pandemic, I couldn't join it. So thanks pandemic as well for that. So yeah, I'm really happy to get to know all of you guys.
I want to say that I'm so impressed from how much you can learn in 9 months when you have amazing tutors. And also through this program, I really felt the freedom with all this software that I could finally express myself through it and do anything I like, because I've been in architecture before and it was really limited. So I'm happy to be here, and I really want to see where this takes me. Thank you.
I'm very proud of you guys. So I'm sure that it's going to take you to some really crazy places. But what you need to do, it's not take no for an answer. And what you need to do is keep pushing harder. Really, even if reality hits, and you still need to work or make ends, or you still need to push and navigate and try to connect, because it's not always the easy path, and we've seen it so much even throughout the team, right? Seeing so many people different time zones, different circumstances, work, family, life is life, and it continues. But beyond that, I think that we're all dreamers in this group, and I believe that there are going to be some really amazing things coming your way for all of you, and you really deserve it.
Also, I wanted to add shortly that we cannot miss out mentioning Tung, who has been an amazing code lead for all of us, and yeah, he deserves a round of applause from us. I mean, he has been
Thank you.
super support.
Yeah, I learn as much as you do, and yeah, thank you all for the passion. I was constantly
Well, in that case, I think Ada also deserves a big round of applause for us.
Yes,
because she's been really supportive. So I think that shouldn't go under the radar at all. So thank you, really appreciate it.
Much appreciated.
I must say, sorry. I must say that this Masters is a dream that came true for our team, for DesignMorphine. It was quite a challenge before announcing it. It is a long story, and this month we are having an anniversary for DesignMorphine. We are turning 8 years, so yeah, it was quite a long journey for us, and thank you so much again for joining the program in its first year. It's great that you had faith in us.
Definitely, that's a big leap, right? Something that it's totally innovative, totally new. Yes. I'm really appreciate you jumping in, and also of course Ada and Tung for all your efforts throughout the academic year. There was a lot to navigate and learn, and go through a lot of different challenges. But I think that it's super rewarding to see how everyone really learned and grew throughout this time frame.
Yes, we all did this together for the first time, so amazing.
Yeah.
I want to, from my side, also congratulate everybody. It was just amazing, what you guys have been doing, and every presentation was just awing us, and yeah, the mentors and DesignMorphine, and it's super awesome community, and it's really nice to have seen you just grow throughout the project and discover things, and yeah, that's just the best thing of that and then you just come out with such beautiful projects. So you guys are all super awesome and badass, and I hope you get some rest and sleep now before you start your new endeavor.
I would like also to say thank you to Svetlana and Pavlina for making this happen and for their guidance and support, and to Michael especially for always also helping us in the background and mentoring us. So yes, thank you for the lead.
Thank you, guys.
Thank you so much.
Where's Michael?
He's
probably in the background as usually.
He's always in the background. Yeah. Well, guys, it was such a pleasure. I will just like say again, like, thank you to, you know, like everyone who made this possible, like to our team of educators, you know, like to Tung and Ada, to Svetlana and Mike, like to everyone that was part of this, to our guests and, you know, like people that support us, and Nook, Daniela, that like you're like still here with us after so many hours. But thank you so much for believing in us. It really means so much that you're, you know, like you're cheerleading, you're like, you know, like supporting us in that way. It's a huge thing when, you know, like it's a new endeavor, like to know that like you're supported and like that the work is appreciated. And of course, like to our awesome students, like we love you guys. We're so proud of you. I'm trying not to to cry again. So really, congrats. Super, super proud of you guys. Take care.
Thank you.
Congratulations.
Congratulations.
Thank you.
Take care.
Thank you.
Goodbye.
Thank you. Bye.
Bye.